Hey guys, yeah, good morning to all of you. Yeah, really glad to see all of you guys joining us early in the morning on a Saturday. Happy 2021 to everybody who's joining us today. This is the inaugural, webinar we host from AWS UG Tirupati. So today's session will be on getting started with AWS, and what a way to kickstart your cloud journey, right? So with us today, we have two great speakers and community leaders. So without further ado, let me just bring them over to the stage, and hope you guys have a good session today. So with us today, we'll be having Suman and Rohini, who will be presenting to you a session on getting started with AWS services. So yeah, without further ado, let me add them to the screen. Hey Suman, hey Rohini.
Hello.
So glad to see you guys here. So um, yeah, so I guess we can get started with the session, right? So it'll be great if you can, give all our viewers a brief introduction about yourselves and what you guys will be presenting today and how the flow works.
Okay.
All right.
Um, thank is the screen shared? Awesome. Thank you. Thanks a lot for that quick introduction. So, hello everyone. Welcome to this session. And first of all, thank you for joining us for this particular topic. My name is Rohini. I am a developer advocate here at AWS. I've been with AWS for 7 years now. I just completed my 7th year anniversary. And I'm joined by my colleague, Suman. Suman, please introduce yourself as well.
Hey, hi everyone. Thanks, Rohini, and many congratulations to Rohini for completing 7 years. I guess she completed just a couple of days back. So wonderful way to start this new year. And thank you so much, everyone who is joining in. And this is going to be our first session of this year. And we are super excited to be with you and show a few of the things that you should be aware of to get started with AWS. And as we all say at Amazon, it's still day one. So we all start from here, what we are going to discuss. So I hope that you gain something in this weekend, and it's worth waking up this early. I mean, 11 o'clock is quite early in the weekend these days. So I'll hand it back to Rohini, and we will come back with other stuffs as the time progresses. Thanks for joining in.
Awesome, awesome. So yes, definitely, and it's definitely our first session of the year. So, demo gods, please bless us, and let's get started. So before we get started, we did want to give a bit of a basic introduction of cloud computing, right? Like we understand that most of you know what cloud is by now because we have been using cloud in our daily lives, right? We are using cloud in general to keep our photos or upload stuff from our mobile so that if we lose our mobile, we can just switch over to another one. But I did want to talk a bit about how cloud computing started because this is quite important to understand if you have to understand how cloud technologies or what cloud technologies actually help you for, right? And this is some problem that started many years ago, and this was around 10-15 years ago. And what used to happen is if a business wanted to run certain applications, let's say it's a bank and they want to run certain applications, or it's a company that is providing certain applications. As the internet started booming, people wanted to access stuff online, for example, even Amazon, right? And what used to happen is companies used to build their own data centers. Now, building a data center means buying a land, doing a lot of installations. First of all, making a building on that land, right? If there is no building, then purchasing these servers, then doing installation of these servers, then a lot of work had to be done for purchasing the servers, insulating the rooms itself because the servers do get hot. Like if you're a MacBook user like I am, you know how hot a MacBook can get when it's doing a lot of processing, right? The same principle applies to a lot of servers. And there, literally, when we used to work in data centers, it used to be so cold we had to wear like thick jackets to be inside, right? So all that work needs a lot of money, needs a lot of time, needs a lot of people to do all that work, from security to installation to maintenance to management of these data centers, right? And then people saw that people used to start renting them out as well. So you could actually just not buy the whole place, you could just buy maybe a rack or rent out a rack and work, go to the data center and work there. But then as the internet started speeding up, and internet started speeding up, and there was a lot of need for people to start building applications on their own, right? And that's what cloud computing helped with. For example, if I have to talk to you in a layman terms, we all use electricity now, right? We all don't go and have our own electricity grids. We purchase that electricity grids over some kind of wire from somewhere else, right? And we use that on a pay as you go basis. The same principle is applicable to cloud computing, where if you want IT resources like compute or some kind of networking, some kind of database or storage, you could access those over the internet, and you pay as you go, as in how much ever I'm consuming, I will start paying for that particular aspect, right? And then that's what led to essentially Amazon Web Services, because Amazon was getting so good at doing these things for its main e-commerce website, that they wanted to give these services, the web services or the APIs, to external people, so that they can start using them in their applications and start building applications in a certain way. So that's what started with Amazon Web Services, right? And then why do people select Amazon Web Services, right? There are a few basic things that I want to get it out before we get into the technical stuff, right? Because that is something important if you're working with a lot of customers, or if you're going to be working with a lot of people that are going to use AWS or projects. You need to understand that why are we using a particular product and a particular service, right? So the first thing is because now cloud made it easier for anyone to be able to access these resources. They actually okay, let me see. Okay. Okay, so let me go back to agility again. So as cloud made it easier for us to get these servers, right? Cloud made it easier for us to buy these resources. It was easier for a lot of startups to, start building applications. Maybe they had an idea, they wanted to start building these applications. So they start building these applications, and then typically quickly try to experiment around it. If it didn't work, they just had to shut down machines and go and start working on a new idea, right? So it allowed a lot of agility where customers could, or people could actually experiment, try some innovative ideas. And that's what we've seen. There was a big boom in the ways a lot of startups started coming up as a business, and they started disrupting the already monopoly that a lot of enterprises had in the market itself. So also cost savings, like I told you, right? Like it's like using your electricity. If you're going to switch off the button, you're not going to use it, you're going to stop paying for it. And if you switch it on, you're going to start paying for it. So that was an easy way. So only pay for what you use. So you didn't have to have a lot of capital expenditure, upfront money that you had to invest to actually start your application and give it out to a lot of people. And it's important to note that AWS has been reducing prices since it has started. I don't remember the exact number. It's somewhere more than 60 for sure. But we have already always reduced our prices for different services or different features, so where customers can benefit from the economies of scale that AWS is seeing at their end. Definitely elasticity. Cloud is virtually like infinite. So you can stop guessing capacity. You don't need to think about, do I need 10 servers? Like for example, you're running a game, right? Your game may become so popular that millions of people want to access your game and start playing it. But it may happen that after some time people may lose interest, or they want to maybe hop over to something, some new hype that has come into market, and the request for your game has come down. You can easily start working with this kind of capacity, where you can add in servers. If you see a lot of demand for your game, you can start adding that capacity. And if you see that, hey, the demand is coming down, and I don't need so many machines to run my, or don't need that kind of capacity to run my application or my game, I can actually reduce it down. So there's a lot of benefits of elasticity. Definitely, we talked about innovation. We talked about how there are business differentiators. You can focus on your business differentiators and not really worry about infrastructure, about how do I get a data center, what do I do about the physical security, and all those aspects, right? And then definitely you can go global. It's now all on internet, right? So I can sit here in India, in Mumbai, and I can create virtual machines sitting in US East. And definitely we have some demos in the entire session. So I'll show you one of the demos where I'll create a server in US East and just access it over the internet sitting here in Mumbai. So now you can not just create applications for your local customers, but you could also create applications for your global customers. And finally, there is a lot of service breadth and depth. So lots of services, we'll talk about that in the session, but a lot of these services do have their own need in the market. Like our roadmap is 90 to 95% of our roadmap is actually based on what customers ask us to build, right? So we collect all this feedback very regularly. We collect this feedback and we understand what are the pain points that customers are facing, and what are the features that they want, that or services that they want, and we prioritize our roadmap based on that. So quickly, what I'll do is I'll show you what AWS and customers, and why I do want to say that this is AWS and customers, but this also kind of applies to a lot of individuals, because in the end, customers are nothing but individuals, right? The end customers who are using AWS as a platform and paying to AWS for using the services are being built by some individuals like you and me. So let's see how customers use the platform before we get dive deep into the technical discussion. So the first thing definitely is that people start with a simple project. You pick up a project that you are accustomed to. For example, you could be a data scientist. You are into data science. You want to experiment with AWS, or you want to get started with AWS. You know, or you could be an operations person. You could be working with Kubernetes in your local environment, and you want to say, hey, how can I run containers and Kubernetes on the AWS platform? Pick something that you know very well, that is something your forte, and try to see how you can run that on the AWS platform. This is the most easiest way to get started on the cloud. If you start learning about the cloud from from nothing, like, hey, I don't know what cloud is, let me start learning, you would learn about it, but you would read about it, but you would not really learn about it, right? So pick a project and do some kind of hands-on activity, and it's the easiest way to get started on the cloud. And this is what a lot of customers do as well. Over the time, they realize that they want to have a lot of the new services that they've built, new applications, the foundational stuff that they've built, they want to move that to the cloud. And they may still have some data centers that would have lease for another few years, so they may still want to maintain that while they are slowly moving to the cloud as well. And ultimately, definitely, that's what migration takes place. If the customer already has some investments, they'll slowly migrate to the cloud. And finally, all these customers, even if they are cloud native or they're migrating to the cloud, they all will start modernizing the application. What we mean is, you cannot just lift an application same and port it to the AWS cloud. You will have to do some kind of changes to the way your application is designed, the way application is going to use the AWS cloud, so that make it more cloud native, you make it more modern, and you are then able to utilize the AWS environment in a better way, right? Then you're going to see all the benefits of what cloud is going to provide. And finally, there is a lot of reinvention that can happen once you're on the platform itself. A lot of customers on the platform. There are a lot of startups, there are a lot of enterprise. Obviously, this is not an exhaustive list. I just wanted to show a few examples that who are the customers of AWS, right? so that if you get an opportunity to work on an AWS project from a particular company, you may be able to understand, are they a startup, are they an enterprise, are they into public sector or government affiliated organizations, or are they something like a system integrators, like your typical names of Cognizant or Accenture or stuff like that, or are they an ISV? ISV as in they have products of their own and they're selling off those products on the AWS marketplace or on the AWS cloud. For example, uh, there is something called as antivirus, right? We have all used antivirus on our personal laptops. Maybe you want to have an antivirus solution for your applications hosted on the cloud. Now, AWS is not into antivirus business, right? But a lot of products are already built for that. You can actually use, for example, Norton, you could use that, or Symantec, you could use that on the AWS cloud on its own, right? So you can launch that and say, I want to run this on an EC2 instance. This is particular virtual machine on the AWS platform, create the antivirus and start using it, and maybe give me a single bill for the entire usage. You could do that on the platform. And that's what we talked about. There are a lot of partners. So there are partners who, the SIs that I talked about, they may have customers who have AWS projects, but the customer doesn't want to do it on their own. They don't want to go with the self-service way. They want some other person to actually help them implement that in their AWS account. And that's what these partners essentially do. They will help them install the servers or create the AWS environment or implement their application in their AWS account. They may also do some kind of management. They may also do some kind of maintenance support for these customers. So AWS will doesn't do hand to keyboard, right, for a customer, because we have customers that could be competitors to each other. But then these partners help these customers implement them, right? Before I move on, I do want to stop and check if Suman wants to add something that I may have obviously missed. Suman?
Yeah, I guess what we just discussed. I think it's quite a exhaustive topic, and there are many use cases. And one of the way that you can get started with it is, as Rohini mentioned, you have to pick your stream and get started with it. Okay, so that's the best way that you can leverage your existing learning. It's not like cloud is it's not something very different. It's just the way the things have been deployed, and the way that you run your application is a little different. So the best way to dive in there is, start whatever you are doing on-prem and just try to replicate that, on the cloud. I can tell you from my journey, I worked my whole of my career in on-premise, and there were times that we used to buy servers for testing and QA. And these days, when I look back, if I have to do the same thing, which I used to take 3 months, it would not take more than 3 minutes, on AWS or on cloud in general. So I guess the way that you can think about it when you are getting started, especially if you are new, just pick your area and get started with it. And going forward, we are going to discuss about how we do and how these services are available to you at scale when we talk about global infrastructure. But I guess this is a good starting point.
Yeah, definitely. I mean, cloud should be like it should complement the knowledge that you already have and not really replace the knowledge that you already have, right? And that's how you have to look at your entire career. Definitely. Uh, Cool. So let's move on to global infrastructure, because I do want to give a quick understanding about the global infrastructure that we have here at AWS, because it's something that we have started since cloud started at AWS, right? Since AWS started, we have been using this methodology of having high availability and being able to be a reliable platform for our customers to use, right? And since its inception, you can see that we have been launching more and more and more regions across the world, because customers have been demanding that they want the cloud nearer to them, or they want cloud where there is some data privacy laws by the country itself, and there are different laws that countries have in its own. So customers have been asking that. So we have announced 5 more regions. The reason we are showing this to you is currently we have Mumbai as the data center or region of AWS in India. We have also announced Hyderabad as a second region in the country itself. That has been announced, and it should be here, I think, 2022. I think next year it should be up and live. So that's what you need to know. Let's go into the important topic about the region design itself. This is very important if you are planning to go do any kind of certifications on the AWS platform, even an associate certification. Knowing your regions and availability zones is the very, very basic that you have to understand about the cloud, right? Because a lot of questions will come around that, and a lot of services are into this AZ regional kind of placement, right? So let's talk about it. Like I mentioned, data centers, right? Customers had to build data centers. So essentially, what we have built is data center in the end, right? Everything is in a data center. But now, what we want to say is our core constructs are availability zone and regions. Now, let's see what is an availability zone. So, an availability zone can be one or more data centers at an AWS end. We don't really disclose how many data centers are there in an availability zone. It's one or more data centers in an availability zone. Now, availability zone itself, when we say one or more data centers, and let's say this is an availability zone and there is another availability zone, both of them will have redundant power supply. What we mean is that the availability zone will have power supply from different vendors, will have network from different vendors, so that even if one of the vendor fails to provide the internet, we will still have a backup to fall back to, right? Even with respect to power, we have a lot of work done with respect to having how much backup power we should have, and what kind of connectivity we should have, and how they are separate from each other, so that if there is any breach, that should not impact a lot of our customers, right? If there is any breach, it has not happened till date, but if that scenario comes in, we have to always think about failure and work backwards from there. So the design itself is, let's say, multiple data centers form an availability zone, and multiple availability zones form a one region. Okay, so what we mean is every region will always have two or more availability zones that make up a region. Now you would say, why go ahead and do so much work, and you could just create one data center and call it a region? The reason is that we want to have a multi-availability zone kind of an architecture for high availability, high scalability, and high fault tolerance. Now, let me give you a quick example. If you have two availability zones, and as a customer, you have hosted your application in both the availability zones. For some reason, even after having so much of redundancy, let's say there is a flood in one of the availability zones, right? For some reason, this availability zone is unresponsive. Your application, even if it is degraded at a 50% capacity, will still be continuing to run from another availability zone. And while this availability zone will have spare capacity itself, the application can start expanding into this availability zone while this availability zone is recovering, or AWS is fixing what is wrong with that availability zone. So in the end, if you think about the multi-availability zone architectures, it helps you create applications that are highly available, even if it's a fault at AWS side, or highly fault tolerant, right? Before I move on, Suman, you have anything to add here in case I missed it?
Yeah, so I think you covered everything, but one key thing that you need to remember that this is how our infrastructure is laid out. And when we come up with any service, any new service, we try to deploy or start the service in one or two regions, not in all the regions, just because we want to know the feedback from customer. And before we roll out to all the regions, we want to make sure that our service is quite reliable as per the customer's requirement. So don't freak out if you go for a service and you select some region and you don't see that service available in that region. So always you need to check that which service is available in which region. Most of the services that you are going to get started with will be available in all the regions, because we are going to discuss all the core services today. But if you pick any new services that we launch, and we launch at a very high acceleration, so it's very difficult to cope up with the new services and capabilities that we keep on adding as we speak now. But there is something that we need to keep in mind, that this is how our whole infrastructure is laid out. And when you pick any service, you are quite confident that your data is being replicated across multiple resources or infrastructure, so that you don't have to worry about how the data is laid out. All you have to care about is your application or whatever you are building on AWS.
Perfect. And yes, good point that we will always, it's on you, right? It's a self-service platform. So you decide that you want to keep your data in the Mumbai region, any of the availability zones, you want to keep the data in the Mumbai region, unless you ask the service to replicate it to another region. AWS is never going to do that. That is because of the data privacy laws that we have to abide by. So AWS automatically will not move it out of that country or out of that region unless you ask the service to do it, right? So even if the region design is like this, it's still isolated from each other, and you as a customer should take care of how you want to replicate it, how you want to design the entire redundancy of it. While I have you here, Suman, I think you should talk about the next slide because we have a fancy demo about this.
Yeah, sure. So one of the things that it's very crucial, and you might have seen in the previous slide that we have roughly around 24 regions as of today. So, but we have a huge area to cover, right? But what we typically do is when we pick up a new region, it's typically in a very a location which is a kind of a metro or a central region where we have lots of client base. But oftentimes, your application will be used, like your customers or your end user would be across the globe, right? So let's say you put some object, or you have placed some data in US region, and your application is being accessed from Bangalore or Pune. So it's quite obvious that there will be some latency, right? Because we cannot go against physics. But that latency may not be visible to you in first place, but for a very highly critical application, that might be quite significant. So that's why we have something called CloudFront or edge location. So these are not fully blown data center or availability zone as such, but that is mostly used for caching. So the way that you can think about it, if you are very much new to cloud, is when you have a laptop or a computer, we have L1 cache, L2 cache, L3 cache, and then we have RAM, and then we have drive. So this is the hierarchy, right? Whenever a data need to be accessed, it need to be checked in L1, L2 cache, and then it goes to RAM. And if it is not available in RAM, then it goes to the hard drive, right? So similarly here, when you put some data, in some region, you can think of that region as hard drive. And then you want to access it from, let's say, Mumbai, right? And Mumbai might have a edge location where it will be cached the data, right? And if that data is not available in that edge location, it will go to the regional cache, which is kind of a RAM, as you can think of. Because regional cache, what it is it's quite bigger than the edge location, and one regional cache caters to multiple edge locations. So then it will check in the regional cache, and if the data is not there in the regional cache, only then it will fetch from the origin, right? And we are going to have a demo in that after some time. But this is how it works. So it's not that if your data is there in US region or in Singapore region, and you are trying to access it from, let's say, Russia or maybe from India, you will not get a latency. And there are different mechanisms, and there are different ways that how you can make these edge locations updated with your data. And we will talk about it when we go to that demo section. But just the thing to keep in mind is, we don't only have regions and availability zone in our infrastructure portfolio, but we do have something called edge locations, which you can think of it as a caching layer, where it will cache the data from the original regions for all of your customers who to get a better latency and better throughput. And we also have a regional cache which caters to multiple edge locations. Okay, so we are going to have a demo now. So before that, let me share my screen. Okay, I hope the screen is visible. So maybe the font size is a little small. I'll expand it. So, but before we go there, what we are going to do is I have opened something called Cloud9. Okay, so this is a Cloud9 environment. So what is that? So one way that you can write your application or start developing it is on your laptop. But a smarter way to do it when you are working on cloud or on AWS is to use Cloud9. So let me show you what Cloud9 is before we get into the CloudFront and S3 demo. So Cloud9 is basically an service where you can have an instance, a developer environment, which will give you an IDE kind of look and feel. So let me show you how it works. So I have just created one environment, but the way that you can create an environment is you can click on create environment and you can give some name. Let's say my dev setup. Okay, and what it would do is it will create an EC2 instance in the backend. So Rohini will show you how you can create an EC2 instance and what EC2 instance is. But for the time being, you can think of EC2 instance as a virtual machine on AWS. That's what it is, at its core. And then you can click on next, and you can select the type of instance, which is nothing but you define how much RAM or CPU and storage you would need. Okay, and the platform. This is nothing but what operating system that the system should have. So let's select Amazon Linux 2, and we can also select whether we want this system to be up and running always, or we want to go into hibernate mode so that we don't be charged when you are not working, right? So by default, it's 30 minutes. So let it be 30 minutes, and I can click on next step, and there is a small summary. And once you are fine with that, you can just click on create environment. Okay, so this will take some time, and while this is going on, I'll switch over to the Cloud9 instance that is already running. Okay, so this is the environment that you will see once the environment is up and running. Okay, so now this is kind of a Linux machine on the cloud, right? And it's an IDE kind of environment which you will get. So you will get a CLI, and you will get a editor. So let me show you this. So if I open this README, here's the editor. So you can write your code, save it, and you can check in your GitHub, everything in the cloud. So you don't have to carry your laptop everywhere. Okay, so that's the whole point about Cloud9. So it's a IDE environment on AWS where you can start developing. Okay, so now coming back to our demo. So what we are going to do now in this demo is, first, we are going to upload an image or a file in S3, and then we will try to create a website, so static website. So what we are going to upload is a simple HTML file, and we would like to have a website which would be hosted on AWS. Okay, so let's see how we can do that. So the first thing is, this location, this GitHub repository will be given to you, where you will have all these 3 demos. These are very small demos, but you can play around after the session. So first, let's go to this folder where we have that file. Okay, so here I am. Okay, so now if you see inside that, there is only one file called index.html. Okay, so now the next thing is we need to create an S3 bucket, and we have to upload this object. Now, what is S3 bucket? So let's open S3. I guess I've opened it in another tab. Yeah. So let's search for S3. So this is the S3 service. So S3 is nothing but an object storage service from AWS. So you can think of it as a place where you can just dump your data, and that can be accessed, from anywhere, and not only from outside AWS, but also from all the AWS services. So you can think of it just like how you put any object or any file in a Dropbox or any of the hosted service as such. So now what we are going to do is we are going to create a bucket. So one way to create a bucket is simply through UI. So you can just click on create bucket and do it. But we are going to use CLI to create that bucket. Okay. So the way that you can do it is you can use AWS CLI, and once you install it, since this is a Cloud9 environment, AWS CLI comes in built. You can say AWS S3 MB stands for make bucket, and then the bucket name. Okay, so let's try to create that. So now this bucket got created, right? So now let's go to that UI and see that if we can see that bucket or not. So let me search for that bucket, and you see that it just got created now. And inside that, there is no files. Okay, so I guess I have created this bucket beforehand, but I have not deleted it. Yeah, I guess I've created that, not deleted it. So let me delete this. Okay, so this bucket got created. It was actually created before because I did not deleted that, but there is no object in this, right? So let's now copy that HTML file in that bucket. So this is my HTML file. So the way that we can upload is we can again use AWS CLI. So it's same as before, but in place of MB, we are using CP, right? Just a simple, copy command as we use in Linux. So let's try to copy this. So now it got uploaded. Now let's see this. Let's refresh. And you see that this file is now available. Now there is an HTML file. If you want to see it in a Cloud9 environment, you can just open that HTML file, and this is an HTML page, right? So now one way that you can host this file as a static web page is by using a static hosting property or a feature set of S3. And to do so, now you can come to properties, and if you scroll down, you will find a static web hosting option, right? So if you now it is disabled, but if you go edit it and enable it, in that case what would happen is it will S3 will give you a link which you can access, and that link will direct you to that index.html file. But that is not always a good practice. There are a couple of reasons for that. One is, in that case, you will be exposing your bucket name to your customers, and second is you have to make this bucket publicly available, right? That is not a good option, right? So now what you can do is you can use CloudFront in front of this, and then you can host this web page, right? So now let's see what CloudFront is and how we can use it. But before we go there, we need to understand few of the concepts in CloudFront. Okay, and these are origins, distribution, edge location, and regional edge locations. So edge locations and regional edge locations we have already discussed, where edge locations is kind of a local infrastructure which will host as a cache for your data. And regional edge locations are larger than edge locations that provides another layer of caching. This is the simplest way that you can think of. But there are a couple of more things that we need to understand before we get into the demo. The first thing is the origin. So in CloudFront, what you do is you first create an origin, and the origin could be anything. So in our case, the origin would be an S3 bucket, right? So this is where the actual data resides. So we have to first, set that up. And then what we do is we create a distribution. Now, distribution is the configuration part of CloudFormation, and this is what gets deployed in all the edge locations. So you can think of distribution as the configuration part of CloudFront. Now, let's go and create a distribution. So for that, we need to first go to CloudFront. So this is CloudFront, and let me just zoom out a bit. So I already have a distribution because it might take a little bit of time. That's why I've already created one, but we will walk you through to create another distribution. So now we have to first create a distribution. So we click on create distribution, and then we are going to get started with web distribution. So there are two ways, two offerings that we have. One is for RTMP protocol, that is for real-time streaming, but we are going to discard that service very soon. But most of the time, and most of the customers who are going to use who are using CloudFront is for web hosting. So let's click on get started. So the first thing that we have to give is the origin, right? That's what we discussed. So in our case, it would be an S3 bucket. So let's search for our S3 bucket. So it was my S3 demo bucket, right? So this is the bucket that we had created. By the way, one more thing that I did not mention is bucket name is universal across the globe. So it need to be unique, not only within your account, but across the globe. So that's why I kept some weird name, like some randomness, I added 1, 2, 3, but bucket name is, it should be unique, right? So this is something that you need to keep in mind. So now we have set that origin, and there are lots of configuration. We will not touch upon all the configuration now, but just to give you some intuition of a few of those options. One of the options is origin path. So this is when within your bucket, if you have multiple folders and you want CloudFront to just redirect to one particular folder, here you can give that path. For our case, since the index.html is in the root root of this bucket, we don't have to give any path. Okay. So the next thing is we need to have we need to give some restriction to the bucket, because that is the whole point of using CloudFront, that we want our bucket to be isolated, not accessed from public, from everyone outside your account, right? So what you can do is you can click on yes, and that means that your bucket, this bucket will have a restricted access. And to show you this, let me go to that same bucket where we have that data, where we have stored that index file. So it's my S3, yeah. Now, if you go to permission, it has all the public access blocked, right? So we don't want this access. All we need to do is here we will say that restrict this this bucket or from accessing from outside, but we want only CloudFront to access this particular bucket, right? So now to do so, there is something called origin access identity. That means you can think of it as a user of CloudFront who can only have the access to this bucket, right? So you can create a new identity, right? You can give some comment, you can create a new identity, or you can use an existing. So I already have an existing, origin identity. That's what I'm going to use. You just mention that, and then we want this policy to be updated in the bucket, right? So you can click on yes, and that means that your bucket policy will be updated, right? So bucket policy is kind of a JSON document you can think of, where you put all the rules that what this bucket should be exposed to. So who can access this bucket, right? So this is what bucket policy is. If you say no, then CloudFront will not update that bucket policy, and you have to do it manually. And if you say yes, it will update the bucket policy. Okay, so it will not change the existing policy. It will just append to the policy whatever rules you have already set. It will just append this particular rule. Okay, so once this is done, the other important thing is you want HTTP or HTTPS. So let's say we go with HTTPS, because that's the most secured protocol, and is one of the safest option that you can go for. And then there are a lot of options that we can set, but for the time being, we can leave all of these. And there is one more thing that you have to do is here. So here we have to mention that, okay, now CloudFront will give me a URL where it will fetch the data that you have stored in the origin, and in our case, that's S3. But what data should be shared, right? So because in that S3 bucket, there might be multiple files. So we can say that here, we want that index.html. Okay, so that means that whenever CloudFront, once we create this distribution, CloudFront will create a URL for us, which will be you can use through HTTP or HTTPS. But when any user goes there, it will redirect to this particular file, right, in that bucket. So let's keep this as index.html and then click on create distribution. So once that is done, you can come to distribution, and you will see that this is in progress, right? Because now what is happening is now that configuration, and distribution is the configuration part of CloudFormation, right? This configuration is getting propagated in all the edge locations. So it might take a little bit of time, but we already have created one CloudFront distribution beforehand. So let's click on that. So once this is deployed, and once you click on this, you will find a domain name, right? So this is the custom URL that got created for you. So let's copy this and let's try to paste it here. Okay, so now you see that this is the same HTML file which we have copied to the S3 bucket. And if you see that this is a secured connection, and if you come to the certificate, and if you come to the details, you will find that this uses a signed certificate from Amazon, and it uses a wildcard that any URL that starts from that ends with cloudfront.net, your browser is going to certify that. I mean, it's a good and authenticated link. So these are the things that you can do with CloudFront. But look at this URL. Your customer have no idea that from where this HTML file is coming, whether it's coming from S3 or whether it's coming from any other resources like load balancer and so on and so forth, right? So this is one of the key things that for you to remember, apart from the caching advantage, that although your S3 bucket is in US and I am accessing this from Bangalore, my data is not getting fetched from US every time, right? So it must be somewhere near Bangalore, with whatever is the edge location near India. This data is coming from there, right? And we quickly went through that UI wizard, but there is something called a time to live, right? Where it will cache the data in that edge location for certain time, right? And once that time expires, it will invalidate that data. And then after that time, whenever a user comes in and access this website again, it will go and fetch it from the origin. Okay, so it doesn't pull the data. So basically, it doesn't replicate the data always, for you. So it all depends on how your user access your CloudFront link to get that data back. Okay, so that's about CloudFront and S3. And we will move on to the next session, next topic. And if you have any questions, do post it, and we will address that towards end. Back to you, Rohini.
Thanks, Suman. That was a detailed demo. Can we have my screen shared, please? Thank you. Great. So Suman talked about CloudFront and we saw a nice demo. I'll just quickly talk to you about Direct Connect and the global network, right? For making all of this possible for you as customers. I think I didn't share my camera, so let me do that. So making all of this possible for all of you customers, AWS has been investing in a lot of network across the world, right? And there is something called as Direct Connect, which a lot of enterprises or a lot of customers who don't want to really go via the internet, because we all know how internet latencies are playing its part, and these customers want a dedicated line towards the cloud or the region that they have been using. There is something called as AWS Direct Connect, which is like you can think like an MPLS lease line that customers can buy, and they can have direct access from their office or from their data centers to the AWS cloud, right? So let me try and show you what we are talking about when we say AWS is huge. There are a lot of breadth of services, breadth and depth itself. So if you see this, don't get scared. I know it may be even difficult to read what is written on a lot of the text. Don't worry, it's not service names, it's just the categories that we want to highlight as to what all services AWS provides, right? So stick with me. If you see the arrow on the screen, we started with infrastructure, right? We talked about regions, we talked about availability zones, we had a demo about cloud, the CDN, and we talked about the points of presence across the world, right? So that's the base infrastructure on which AWS sits today, right? And on the base, we start with core services. And these are services that have been released years and years ago. They have been used by a lot of customers. So there's a lot of depth in a lot of these core services that AWS has, right? So when you're starting with the cloud, it's very good to start from the core services, because everything else that you see built on AWS is built on these core services. Okay, so we eat our own food, or we eat whatever we have produced. So a lot of the services that AWS has today are built using these core services. So knowing the core services is very important, especially if you're trying to do some certifications. You have to go through the core services. So we will give a small demos about each of these during the session. So we already covered storage like at S3. We talked about CDN with cloud from front. We'll talk. We will have some demos around compute. We'll have some demos around the networking and a lot of other managed services. Well, you may understand that the data that you're hosting is into someone else's data center, which you may never actually get to visit, right? Because we can't let customers visit our data centers. If we have to do that, then all of them will visit the data center and we'll not be able to manage the security, right? So we don't let customers know where the data centers, like even as employees, we only know that it's in Mumbai. We don't know where in Mumbai, right? Uh, it's a very confidential information, and we take security, as the number one priority for us, because we are dealing with data that is very important to a lot of businesses, to a lot of companies, right? So there is a very comprehensive security portfolio that we have in AWS, and I do have a slide or two on the security aspect on the platform. Then we see a lot of analytics and DevOps and mobile services and IoT and machine learning and a lot of hybrid environments, because we still understand customers do have their investments into data centers and may not want to just cluck it and then move on to the cloud. They will still want to retain those because they have made these expenses already, maybe for many years to go, and they're slowly moving to the cloud. So we do want to give those hybrid capabilities to customers so that they're able to use the data center investments and also use the cloud for expansion, right? So there are a lot of services that are oriented around these, and what we call them are managed services. Now, in old terms, we used to say infrastructure as a service and platform as a service and software as a service. We don't really categorize our services in that. We say that these are core services, and everything else that sits on that is like a managed service. And definitely I have a slide on that as well, but this is just to give you an idea of the kind of services AWS provides. Then you see the marketplace, like I mentioned, right? We are not into antivirus business, so we use a lot of our ISVs who are building these applications and use them on the AWS platform. And apart from that, there is entire ecosystem of a lot of people who help a lot of customers. So if you're looking at, I get a lot of questions around what are these different roles that AWS has, or hiring perspective, and what kind of people work at AWS. There's a lot of people that work here, right? Apart from the developers and the product managers who actually build these products and build these products for the platform, there is a support, premium support, and section of the AWS platform that does help with customers for their technical questions, for troubleshooting, or anything they need help with on the AWS platform. Then there is a paid professional services that AWS provides if customer wants AWS to get into their account, to get into their use cases and help them with certain solutions on the AWS platform. Then we have the partner ecosystem that I talked about. There's a training and certification team. We are definitely going to talk about training and certification towards the end. We have a solutions management team, or a sales or a pre-sales team, or an account team, which helps customers get new use cases on the platform, understand the platform. There's a solution architecture, solution architects, and technical account managers. There are a lot of people who help customers when they are on their journey on the AWS platforms. Remember that graph that we saw, right? So there's entire journey that customers have need help with, and that's what these people do, right? So now that I have told you that there are so many services, you don't have to worry about a lot of these services. You start with what you know and see how that works on the AWS platform, and then you start with that. But if you're doing certifications, definitely look at the core services and security, because these are most important when you're preparing for the questions there, right? So when you have to interact with AWS, Suman showed you a couple of ways. One is the web console or the management console, right? Then you have the then you have the command line tool that Suman showed you about, right? Like he had already installed that in somewhere in Cloud9. We will see some other ways as well, but you can have this command line tool installed on your Linux machine or your Mac machine. Use the terminal, and even in Windows, it's possible, right? So you install that, you configure the credentials so that it can speak to your AWS account. And there is also IDEs like one Cloud9 that someone showed, or you could use Visual Studio or any local IDEs that AWS supports. There's a lot of them. You can use that. Definitely, there are a lot of SDKs. Now, because these are web services or APIs, we have SDKs in different languages, and you can pick up whichever language that suits you, you are good with. You can pick up that language and start using the SDKs of AWS in your application, right? And the last one is definitely infrastructure as code, where someone mentioned about CloudFormation, or you want to use Terraform or other tools where you can write your application in a template format, give it to AWS or give it to Terraform, and let them create the resources that you need in the AWS account in the backend. So you don't have to go and do click, click, click in the console, or you don't have to write commands. Not a lot of commands, but you may have to do some kind of activity there. But you define a template and give it to the cloud, and the cloud takes care of calling all these APIs, right? Uh, I think there was some point I'm missing here. Suman, did I cover the SDK parts, or do you want to add something here?
No, I guess that's perfect. And we are going to see how you can use a Python SDK while we discuss about Lambda after some time. But yeah, the point being is, you can use anything like UI, CLI, ID environment, just like how we shown a moment back on with Cloud9, and any SDK. Which, if you are a developer or an architect, most of the time you'll be using some of the SDK of your preferred language. Yeah.
Yes, definitely. And so moving on, I did talk about pricing, right? Pay as you go pricing. Now, a lot of people ask, like, I'm getting started with cloud. How do I experiment easily? How can I check out what cloud is? There is something called as free tier on the AWS platform. Now, free tier doesn't mean everything is free. Obviously, we are not, in that kind of business where we can give everything free. There are so many things to be looked at. But what we say is there are a few things that you can look at. Okay. So let me first start talking about 12 months free. I think I should put it up. But there are, when you sign up for a new account on AWS, okay, you get a 12 months free tier in your account. Okay. It's for new signups itself for initial 12 months. What we mean by free is few resources in few services are free for you to use. Okay. And once you use up that quota, for example, if 750 hours per month is for T2 micro is available per month, if you use up more than 750 hours, you will start billing for that particular thing that you've started and you've not shut it down, right? So if you're experimenting, know what you're launching, is it within the free tier limits, and shut it down as soon as you don't need it, so that you stop paying for it. And even for EC2 instance, don't just shut down, just terminate and delete all the storage that you have if you don't really need it and you're just experimenting. A lot of services have something called as always free. So it doesn't care if it's a new account, it's an old account, it doesn't care. It's some resources are free all the time. And if you use beyond that capacity, obviously you will be charged for that. And for some services, we also have trials. So for example, you want to play with Redshift. I don't think I mentioned that, but if you want to play with Redshift, or you want to play with a lot of our services, we do give free trials for customers to use. Generally, this is available with a lot of services that are in beta or in preview mode on the platform. So let me quickly start talking about the compute options, right? And we do have a demo coming up, so we will definitely go deeper into the demo itself. But when you have to think about compute options on the AWS platform, think of these three major categories. Obviously, each category is deep enough to talk about. Like, it may take an entire day for us to go and talk about them. But let me give you a quick understanding. Uh, when we talk about cloud, right, there is something you have to understand, and you can go and read this. This is a stretch reading that you can have. Uh, is about physical infrastructure and how hypervisors are used on the physical infrastructure to abstract the physical infrastructure into virtual machines. Okay. Virtual machines in the cloud are nothing but any machine that you need, and this could be with operating systems, typical operating systems like Linux, Windows, Red Hat, or even Mac OS on the AWS platform. Yes, recently, I think November, December, during reInvent, we announced that we started supporting Mac operating systems on the AWS platform, and this is something that is we are doing for the first time. So definitely, if you have the budget, go ahead, try it out, and we are always looking for feedback as to your experience on the AWS platform. So the first abstraction layer is the EC2 instances, okay, the virtual servers on the cloud. Then you know how the abstractions work, but then there is containers. You can run on containers platforms on these EC2 layers. You could have your orchestration layer like Kubernetes or something like ECS that AWS provides. About that, you could also have another layer of abstraction of being serverless, right? uh, Serverless means doesn't mean that there are no servers. Okay, there are servers, but the servers are managed by AWS. Remember, I said there are core services and there is managed services. So in these services, the serverless layer is been managed by AWS. You have to worry about your application, you have to worry about your application code, you have to worry about your application. For example, if you're using Fargate, where you're giving it a container image, you have to worry about how you're bundling that container image or how your application architecture is. You don't have to worry about how am I launching EC2 instances or not, right? So definitely there are three different layers that we're going to look at. So I'm going to show you the EC2 demo, and then we'll switch over to Suman's screen for the Lambda demo that he has created with Python. Okay. So let me quickly see if you can see my screen. So that's my screen. Before I get into EC2, I saw a question coming up in the chat. So let me show you that. So there is something called as AWS Cloud Shell that we have announced recently during reInvent, AWS reInvent conference that we had. And what does Cloud Shell does is nothing but the CLI, or the command line input that you would have. Instead of you installing that on your local machines, or maybe even you want to go and use Cloud9, but if you don't want to install it on your local machines and you still want to use the CLI, you don't want to go through the headache of configuring it and updating and all that stuff, you could start using AWS Cloud Shell. Okay, and Cloud Shell is nothing but I just selected that service, went here, I wrote Cloud Shell, and that's it. It's a browser based CLI from AWS in the AWS Management Console. Okay, so as simple as that, I can just say AWS EC2 describe instances, and it should be able to go ahead and check out all the EC2 instances in this particular region that I have, and it will start showing it in the JSON format that is by default. I can also change it to table or whatever format I need. So that's Cloud Shell, and you can easily use Cloud Shell. Today, you can definitely have different layouts. You can download. The best part is you can upload and download your files from your local machine to the CLI as well. And that's it. Like, there's nothing much to talk about Cloud Shell. So let's go and talk about the management console. So when you launch to AWS Management Console, this is what it looks like initially. So there are a few solutions you can quickly play with here if you're new. Uh, Things to note. First thing is your account details, your billing details all are available here in this pane. Then you go to uh, this part where I'm saying US East, you can select the different regions that you have, right? So if I have to, let's say, for example, launch in Mumbai, I would just have to click here and it will take me to all the machines that all the resources that I've created in Mumbai region. That's as easy as we can make it to switch between different regions that you have in the AWS platform, right? Uh, So you can have support center if you need help. You can have public forums. Don't want to pay for anything from support. You can go and check on the public forums. You can check the documentation and more information. Now, this is a new thing that we launched where you can search, everything. Like if you want to search for services, you want to search for documentation, you can just click here, or you can start searching for these different resources. Coming to the left, there is services. Uh, Services, you can see a lot of services, right? Remember, I said 175. There's a lot of services. Don't worry. Just favorite most of your services or just search for them here and you should be okay. Okay. And so let's do this. Let's go to EC2. I do have some information on the networking aspect. I've created fancy architecture, so we'll go to that demo later. So what I'm going to do is quickly, don't want to take a lot of time. I'm going to show you how you can launch EC2 instances. Okay, it's too messy. Just click on this orange little thing. Click on launch instance. Okay, I want to launch instance. Now you can see there are many steps on launching an EC2 instance. Okay. The first thing is I need to select my operating system. What do I need? I need Amazon Linux. I need Mac OS. Do I need Red Hat? Do I need Windows? What do I need? Do I need Ubuntu? What do I need to launch? What is the base image or base template from which the virtual machine will be created? To keep it simple, I'm just going to select I need Amazon Linux too. It's similar to your CentOS. So you can start using Amazon Linux too. I can select what kind of architecture I want with it. If I have my own AMIs that I've customized, I can also use those. I can use from something from a marketplace, like I need Trend Micros AMIs, or I need OpenVPN. I can start using that. I can also start, filtering it out further if I need anything. So I'm just going to go with quick start and select it machine. Okay, now let's give it a minute. Now you select an instance type where you select what is the CPU, what is the memory configuration that I need, what is the storage configuration I need, is it EBS, is it instant store? There's a lot more to talk about it. I'll skip it. Don't worry. Just go with an EBS launch as of now. But if you need to have a more detailed information, we should do another session for that. But you'll understand a lot bit easier. Now, this is free tier eligible. We talked about free tier. And you can understand that this has 1 vCPU and this has 1 GB memory. I think it's okay for a demo, right? So let's go and stick to T2. There is lots you can search from. Okay, so I'm not going to go there. And I can just review and launch this. No, but I want to show you what you can do, right? Now, here you can configure the instance details, right? Now, let me do this. Now, I can say how many machines I want. I can say 1, I can say 100, I can say 10,000. You cannot launch 1,000 instances if it's a new account. We definitely have some soft limits placed into your account so that by default, you don't like just go ahead and launch 100 instances and then you start paying for it, right? So there are soft limits in your account that you may need to increase if you need a lot more than maybe 20 instances to run. So I've already created a VPC. It's like a logical isolation in the AWS environment. I will go deeper into VPC later. So bear with me what I mean by VPC, virtual private cloud in the AWS environment. Okay. Then you have a subnet. I could say, do I want it to be publicly accessible, like over the internet, or do I not want it to be publicly accessible over the internet? I want to because I want to show you the demo. And I'm just seeing what are the other features. We can just ignore most of them by default. You could say, what do you want to do when you say shutdown? Does it want to stop or terminate by default? There is something I do want to show you is the advanced. If you by default, sometimes this is closed. Just click on that. And there is something called as user data, which you can pass. Okay. So when your machine is booting up, when your operating system is booting up, you can pass a lot of commands to it. So while it is done booting, it will execute this information for you and keep it ready. Now, this happens only the first time the EC2 instance is started. Okay. If you stop it and start it again, it will not execute. So it's the first time when a new instance is created, this will be executed. What I'm saying is I want to just update the operating system. I want to install maybe HTTPD and be able to access it on my browser. Okay, as simple as that. Then I can add storage if I need. I can upgrade the storage. By default, it comes with 8 GB. I can add new volumes that I need. I can say how many 100 or 8. What is the type of volume I need depending on the use cases. And, do I need encryption or not, right? So I'm just going to delete that. Okay. And it's also delete on termination. So if I terminate the instance, it will automatically delete this volume. Typically, if you're hosting your own database, you may want to untick this, because then you terminate the instance by mistake, or you want to terminate the instance but retain the EBS, you can do that. Next is add tags. This is very important. Many people don't do this. This is very important. You give a name, you give it a purpose, you give it what environment. Is it production? Is it development, testing environment? What environment is this? You need to tell it, so that you can later on understand who's using resources a lot more, and what are you paying for. It's easy to search as well. It's easy to identify what you're doing with these volumes without going inside. The next important thing is security group. The security group is nothing but, like, think of it like a firewall rules that you're going to apply to your virtual machine. So you don't have to go inside and set IP tables if you're working on it. You can apply the security group firewall rules from outside. And we have that demo, but you can apply the security group from outside and ensure that you're able to have only required access to your virtual machines. Now, I could actually create my own security group. I could create, hey, I want HTTP access to this, and I want blah, blah, blah access. I want it from my own IP, so it automatically picks my IP, or do I want it from anywhere, or do I want another security group to have access to this security group? Do I want to give that, right? So you could also have firewall to firewall communication. What I'm going to do is I already created something, so I'm just going to go ahead and select that. So I have port 80 open for anywhere. I have port 22 and just 3389 in case I thought I'll do Windows as well. So just go to review and launch, and you can just see, everything looks okay, and just click on launch. Now, when you click on launch, it is going to ask you that, do you have a key pair, or do you want to create a new key pair? Okay. Now, this is needed if it's the first time that you're launching a virtual machine and you don't have set any username password set. This is the first time how you're going to access your virtual machines, right? So I've already created one. If you want to create a new one, you just have to mention the name and download the key pair. That's it, and store it securely. But if I'm already downloaded once, I'm just going to go ahead and use that, and I acknowledge that I have that key pair. Okay, now I can just launch an EC2 instance. uh, it may take a couple of minutes for it to launch an EC2 instance. Right now there's nothing else it has done, so we'll just go here and see what is happening with that instance. So right now it has gone into a pending mode. Okay, uh, so let's see the details in the below panel here. Okay, so you can see what is the instance ID. Okay, what is the state? What is the public IP address? What is the public DNS IP? What is the private IP of this instance? What is the VPC? What is the subnet that I've launched it in? Okay, blah, blah. Great, great, great. And then I can see Linux. I can see a lot more information if I've needed. Let's go to security. Security, you can see what security group it has, what are the rules. I know we are not talking a lot about IAM, but there is a service called that Identity and Access Management, which is a very basic service that you need to know of. You need to know when you're working with the AWS cloud. So very basic. You can create users for administrators, users for developers. You can group them all, and you can give them what permissions they have to do in the AWS cloud. Networking, we will definitely talk about that. Storage, you can understand what is the storage, how much volume I have, is it attached, it is not. Status check. Now, this is still running status check. What it is actually doing is it's actually checking if your instance is healthy, does it have any issues, is there any issues with the underlying hardware. So it's actually doing a lot of status checks for you. If it says one of the status checks failed, then you may need to restart it, or you may need to create a new virtual machine. Happens rarely, but it's possible that it happens, and that's why there's the check, right? And monitoring, okay, this takes a little time for it to refresh because the instance is still going booting up, but there's a lot more information. You can identify what is the CPU utilization, what is the networking, what is the disk. So there are by default, I think, few metrics that it shows, and you can definitely know these, and you can add your custom ones if you need later on. Then you go to tags, and you definitely add tags, right? So what I'm going to do is, now I've selected this virtual machine, I've selected here, go connect. Okay, so either I can use, it's taking a while, I don't know why. Okay, so I could either use directly from my browser, or I could use session manager. Let's fuck it for now. Or I can just use an SSH client. So let me do this. Let me get my what it is saying is open your SSH client. This could be terminal. I'm on a MacBook, so I'm using a terminal. Locate the key file that we downloaded. So it's already downloaded. You change its permissions. I've already done this. And you connect to your instance using the public DNS, right? So I'm just, that example is already pre-populated. You don't have to worry anything. You just copy this. Command is copied. And let me just go back and show you how it looks like on my machine, right? So I've already, if you see the key is already here, what I'm going to do is I'm just going to paste that command that I copied and press enter. And because it's the first time I'm logging in, it's going to ask me, are you sure you want to connect? I'm going to say yes. And already added, and that's it. I'm inside the virtual machine. I can actually do typical commands that I've been doing. Okay, so let's go to cd slash, and you can see it's a typical operating system that you have. Now I can install stuff I need. I can create stuff I need. Now, if you remember, I've already given it, and this is the last piece of the puzzle. I've already asked it to, install HTTPD and access that. So I'm just going to click on open address. And by default, open address actually does this. So it goes to HTTPS. I don't have a SSL certificate. I only have HTTP installed. So if I do this, ta-da! So I'm able to see that HTTPD is already installed on that machine, and it's something that I can start with. So this is how you may want to start with bundling your application and push it. There's a lot of other better ways of doing it, but I just wanted to show you a simple way of doing that. Now I'm done with my demo, so I'm going to do the good thing that I should do is go ahead to the instance state and terminate this virtual machine, because I don't want to keep paying for it unnecessarily. And that concludes my demo. I'll switch over to Suman for the Lambda demo. Over to you, Suman.
Sure. Thanks, Rohini. Let me share my screen. Okay, so what we have seen is now how you can create a virtual machine, and that is the most important thing that you would do once you are, getting started with AWS. That's the first thing probably that you would do, or maybe after creating an S3 bucket on AWS to get started with, right? So now EC2 instances are great, and that's the core of anything that you build on, right? But there are a lot of instances where you don't want to manage infrastructure, right? You don't want to anyway when you are on AWS, you are not managing infrastructure, but let's say you are a developer or you are an application designer or architect, and you feel that based on your use case or business use case, it's not important for you to manage these EC2 instances. All you care about is your code or your application, right? And you are asking yourself that, is there any better way that you can deploy your application where you don't have to worry about this infrastructure, like managing EC2 instances, scaling it based on the requirement and all of that. So one way that you can do so is using a serverless, and that is and one of the serverless offering that we have is Lambda, and we are going to look into Lambda. And I know that we have not covered the theory of Lambda, but that's okay, because that itself would be a couple of hours of session. But what we will do now is we will just give you an intuition of what Lambda can do. Okay, so one way that you can think of Lambda is let's say you are building an application which will be used by customers or your end user, oftentimes, right? And it may not be always, right? So let's say your application is to convert a PDF to a Word document, right? So whenever a user uploads a PDF document, your code will kick in and it will convert that into document and it will send it to you, right? So if you have any application which works in this notion where your code should get triggered with some activity. So in our case, in this example, it's an upload of an object which is a PDF file, right? And then your code will kick in and it will create the document and it will send it back to the user, and it's done, right? So if your application is something of these kind of architecture where your code should come into play only in case of any trigger. So we just talk about a trigger being an object upload, but it could be anything. Let's say a message in the queue or anything for that matter. So in those cases, you can use Lambda. So what Lambda is at its core is you can write a Lambda function, and you can enable some trigger so that you are saying a Lambda that, hey, this is my code, and you should get triggered only when you see some activity on this particular resource, right? And then what AWS will do is it will create a container for you in the backend, and it will serve that customer request. And once that is done, it will destroy that infrastructure for you, and you will not be paid. You will not have to pay the bill for your EC2 machine and resources when people are not using it, right? So Lambda is not an EC2 instance, but you can think of it from the container standpoint. If you are aware of Docker, Kubernetes, or any container platform, you can think of it as a, whenever your user is talking to Lambda, it's actually creating some container in the backend, right? So we are going to see a very simple example where we will be uploading an image, okay? And what we want to do is we need to convert that image into a thumbnail, okay? So let's say this is the application that you are developing, right? Where you take the image from the user and it will just convert it into a thumbnail. That's all, right? So it could be anything, but this is, just to show you the power of Lambda. So one way that you can do it is through UI, and you can click on, you just have to search for Lambda, and I've already come to the Lambda console. If you have never come to this Lambda service before, you may not see this page. You will find a splashing screen with getting started, but I have created lots of functions before, so I see this particular page. So now you click on create function, and you can give some name. So let's say demo, okay? And there are different blueprints available. We will not get into that, but let's say you are you are getting started from the beginning, and you can select your language, of your application. So we support .NET, Go, Java, Node.js, Python, Ruby, and many others. So let's say I select Python, and now the next thing is you need to give some roles, right? So because your Lambda function might need to access or need to have some access to other resources, right? So let's say you are defining this Lambda function, keeping in mind that, okay, this function, a Python code which I'm going to write in some time, it should get triggered only when there is an image getting uploaded in S3 bucket. That means your Lambda function need to have the adequate permissions and role to access those objects from S3, because S3 is a different service, right? In AWS, everything is around roles and access control, right? So you need to be very comfortable with that. So, so you have to create either an existing role, or you can create a new role, or whatever it is, right? So let's say I'm using an existing role, and let's say any random role, okay? So we can see what this role is about, what are the permissions given there, but for the timing, let's leave it there. And then you can also, configure a few other things like VPC network and other things. But for the timing, we are not going to set all this up. But all I want you to know is you define what language, what should be the runtime for your code, and what is the permission. This is very, very important. And then come here and click on create function. Okay, so this might take a few seconds to get created. And now that you see that your function got created, but there is no trigger, right? So now if you have to add a trigger, or you have to click on add trigger, and then you have to say what should trigger this Lambda function. So it could be S3, or it could be any other service, right? Kinesis for data streaming, or let's say you have a DynamoDB database, and whenever there is an entry in DynamoDB database, your Lambda function should trigger. Okay, so to give you an example, let's say whenever you order something in Swiggy, right, you get an SMS, right? So it might so happen that whenever you place that order, that order came from got a entry in DynamoDB database, and that database entry triggered this Lambda function, and this Lambda function might do something else, right? It might trigger some analytics. It might trigger to send an SMS or whatever it is, right? So the idea is you should have some trigger. Okay, so you can select this. So let's say for the timing, we select S3. Okay, and then you can specify the S3 bucket, which bucket you want to specify to have that trigger, and so on, right? And after all of these, you have to click on add. Okay, so we will not do this, but I just want to show you what are the things that you need to do when you are doing it through UI. And finally, here is the Lambda function. Here's the Lambda function. This is a boilerplate, and what it has is it has a function, and it has two parameters or arguments. One is event, and another is context. So event would contain the event which actually triggered this Lambda function. So if it is a S3 bucket, then this event will have all the details about what object been uploaded, in which bucket it got uploaded, and all of that. And context is something which is kind of a metadata, like at what time it is got updated, or there are different metadata that follows that particular trigger. So all of that data you can get in this context variable. And then you write your code. It could be anything, right? So this is how you write a Lambda function. Okay, so now we have done a lot of things. You have to do a lot of things manually if you are doing it through UI, right? So there must be some better way. So there are different tools and techniques available to create a Lambda function depending on various languages. And today I'm going to use Chalice. So Chalice is let me go back to this function. Okay, so we are here, and let me minimize this, and yeah, let me show you here. So we are going to use a Python serverless. I would say that it's a tool or framework called Chalice, and this is only for Python. So if you are working in Python and if your application is in Python, then you can surely make use of this. Okay, so this makes life very, very easy. So you don't have to worry about all the permissions. You don't have to worry about making a complete package of your software, because a lot of times, let's say you are creating a serverless application in Python, and there are a lot of third-party libraries that you are using, right? In that case, you need to provide those third-party library details, right, which we typically put in requirement.txt. So all of that packaging and everything getting zipped in a folder and getting pushed in S3, and all of that is taken care by Chalice. Okay, so we are going to use Chalice, and how we are going to use Chalice to create a Lambda function, we'll have a look now. So I'm inside this Cloud9 environment, and I've already installed Chalice. So the way that you can install Chalice is via this simple pip install command, and I have already installed it. So now what we have to do is we have to just create a new project. Okay, so I just say Chalice new project, my Lambda demo. Okay, so once we create that, you see that there is a new folder got created in the left hand side, right? If you see this, my Lambda demo. Okay, so let's get inside that my Lambda demo. And inside this, we see that there is already a app.py file and the requirement.txt. Okay, it already got created. Now, what we are going to do is first we need to edit this file, app.py. And to do so, we can just double click on this. Since we are in Cloud9, we can make use of this environment. And I'm going to delete the boiler code that comes by default and paste this code. Okay, that's a very simple code. What we are doing is we want this Lambda function to get triggered only when there is an upload of an image, right, in one bucket. And once that is uploaded, we will convert it into thumbnail and we will push it back to some bucket, right? So this is my input bucket. Okay, this is my input bucket, and this is the bucket which I want that Lambda to be triggered on when there is an object upload. And this should be the output bucket where I will be storing the thumbnail. Okay, so I'm importing a bunch of packages, and we are using Boto3, which is the SDK for Python, and we are using Pill. So this is the Pillow library, which offers us to resize and change it to thumbnail and all of that. So these two are third-party libraries, and we need to put them into requirement.txt, which we are going to do in some time. So now, first thing that you do is in Chalice, you create a Chalice object using Chalice. So we already imported this particular class, and we say some app name, and debugging is true, so that you can see the logs as well. And if you are into Python, you know how decorators work, but even if you don't know, that's okay, because this is the only line which is different, right? This is where Chalice comes into picture. So all you do is, I have created an app client. So what I'm doing is, I'm saying app dot on S3 event. That means that whatever function is coming here, it should be triggered on an S3 event, right? So that's what we did in UI, right, in some time back. So here we are doing using Chalice. And after that, all this code, this is nothing to do with Chalice. Okay, it's a pure Python code which you can write through the UI as well. So what we are doing, we are first logging, putting some log information, that resizing this image, because this is when your application got, your Lambda function got triggered. And we are using a temp file. So temp file is a package in Python where it can create temporary files. And this is the line number 16, where we are just downloading that image, the photo which got uploaded in the input bucket. And once that is done, we are creating a new file name, and this is the file name of the thumbnail, which would be same as the file name, but with this thumbnail.jpg extension. And then what we are doing is, we are just opening that image using Pillow, and we are creating a thumbnail of 256 by 256. That's all. And once that is done, we have to upload that image into this output bucket, right? And this is what we are doing in this section, right? So we are just uploading through S3 client, and S3 client is something that we have declared here using Boto3. So Boto3 is in Python SDK, and what that means is, you can use Boto3 to access any resource in AWS if you're using Python. So if you want to use EC2, you can just say EC2, right? So if you want to use S3, you just write S3. Okay, so that's how Boto3. You can use Boto3 in your application. So now we have S3 client, and that is an S3 client, and we are just using upload files method, and we are giving this a new file name, which we just converted into thumbnail. Okay, that's all. So that's the code. So let's save this code and close it. Okay, so now the next thing that we need to do is we need to have this requirement file, right? So because requirement file is empty now. So if you click on requirement, okay, I guess, okay, I'm in the different folder. Okay, this requirement file is empty. So we need to add this Pillow and Boto3. So what I'm going to do is, I'm going to copy.
Sorry, one feedback is, can you increase the font size a little?
Yeah,
Or
sure.
maybe full screen? Yeah.
Okay.
Thank you.
Thank you. Thanks. So this is Boto3, and this is Pillow. Okay, so these are the two dependencies that we had. So we are just saving this and closing this. Okay, so now what we have is, we have two files, app.py, which we edited, and we have this requirement.txt, which already got updated, right? So all we need to do is, now we have to deploy this application, right? And to deploy this application, what we can do is simply run this Chalice deploy. Okay, and it will deploy your application. But before I run that, I want to show you that there are some hidden files which it has, and these hidden folders, and inside that there is some configuration details about your Lambda function, like what should be the runtime, and it's a Python package, and there are different other configuration parameters available in this file, okay, which you don't see this. So now let's run chalice deploy. And now what it is going to do is it is going to make a zip folder and a zip file, and it will take all this code and requirement, and it will create an IAM role. As you can see, it's creating an IAM role, and it will push it to AWS, right? So we have not mentioned the region where it should deploy, but by default, it will pick up from this Cloud9 instance, because I'm running this in Northern Virginia, and it takes all those information from AWS CLI, right? So we are done with our Lambda function, right? So now let's go back to our console. So now we are in the console. Okay, so now let's refresh this page. And you see that our Lambda function got created. So let's go there. And we see that there is a trigger added S3, but you don't see the code here because it's little big, and it has zipped the code, and it has sent it to AWS, right? So if you have to edit anything, you can go back to the Cloud9 and edit it. Okay, so all we need to do is we need to now upload an image into that bucket. Okay, so let's open S3 in a different tab. And let me copy the bucket name. So I think this is very small. Okay, so this is the bucket that we have, and there is no object in this, right? So let's upload an object. So I have an object. I have an object in my desktop, so I'm just dragging it, and I'm simply uploading it. Okay, so it will take a few seconds to upload. So now once this file gets uploaded, right? So now that this file got uploaded, what should happen is, that Lambda function should get triggered. Okay, and once that is triggered, that code will run, and it will convert that into a thumbnail, and it will push it to the destination bucket. So let's go back, and let's open the other bucket, which is, I'm just copying it, and let's search for the output bucket. So this is the output bucket, and you see that a thumbnail got created, right? There is a temporary file name .thumbnail.jpg. So now what will happen is this image should contain the thumbnail. So let me download this. Okay, this got downloaded, but before I open that, let me show you the actual image so that you know that the original image is not the thumbnail. So this is the original image. Okay, so now what we can do is we can open the thumbnail which we have just downloaded. So this is the thumbnail which got created by the Lambda function. Okay, so that's how. So now at this point, your Lambda function, it got triggered. It did what what it was supposed to do, and now it's going to destroy the infrastructure. It will keep it alive for some time, but logically, to think how serverless works is, you can think of it as that now you are not charged for anything. You'll be charged only for that particular moment when the code was running to convert that image. Okay, so now the last thing that I want you to show is in this Lambda function, if you come to monitoring, so this is the log stream, and here you can see that whatever or whoever is triggering, you will see all the logs here, right? So you see that there is a log, and not this one. Yes, I want to show you the CloudFront. One second. Yeah, so this is the entry that you see that we had. Okay, so this is the trigger that triggered the upload of that file that triggered this Lambda function. And if you want to go to the details, you can see that the file got. This is when the Lambda function got triggered, and this is exactly the same message that we put in our in our code, right? If you remember, let's open this code. Resize this image from S3 and then the bucket name, right? This is when it got started, right? So same thing you see here. Okay, same thing you see here. So you can put your code in logging information in your code, and you can see that in CloudWatch, right? So, and once this is done, you know that how much time it ran. So it ran for roughly around 704 millisecond, and it uses this much of memory and whatever, right? So that's the beauty of Lambda, and how you can integrate Lambda with various services. There's a very toy example where we just had one trigger with S3, but there could be many complex architecture in real world. So that's about Lambda, and all this code would be available to you to play around. Although these are very simple, but you can explore all of that and build on top of it. When you are getting started with this. Okay, so back to you, Rohini.
Awesome. Thanks for that demo. I'll just wait for my screen to be popping up. Awesome. So we talked about EC2, we talked about Lambda. So let me wrap up what we talked about with the compute options, right? So we talked about EC2 when we launched a virtual machine, and there is a lot to select from, right? I just showed you one T2.micro, but then there is a lot of things that you have to think about. But when you're experimenting, when you're starting, you don't have to worry about that. Just go with T2 micro or the basic ones, and you're okay. But if you're studying for exams, you need to understand that there are different categories. The one I launched was a burstable category, but you have to look at different categories, understand different capabilities that customers can use from, like some want faster, faster storage type, or some want a cheaper storage type, and some want GPUs, or they may just want CPUs, or what kind of networking. So there is a lot of choices that customers have today to select from when they are launching EC2 instances and using them in their platform, right? Then you have containers, right? And I didn't want to go deeper into this. Don't worry about the links. We'll give you the links towards the end. But the links, what we mean is that if you have EC2, or you could use Fargate, which is one of the serverless aspects. Like in Lambda, you gave the zip file, or someone gave the zip file or the code, and it executed that code based on the trigger. The same way you can work with this Fargate, where you give it a container image, and it will execute that container image as long as the processing needs to be done, and then goes back to sleep. So you only pay for the time that your container was running, or for the time that your Lambda function was running, and you only pay for that. So that could be milliseconds instead of running a virtual machine and not utilizing it at all, right? So that's the way you have to start thinking about when you're working with it. But from an orchestration perspective, there is ECS and there is EKS. There are two different services. ECS has been in the market for like last 4-5 years. EKS is relatively new. It's been 2 years almost for EKS to be launched. If you want to play with these are the very nice workshops that we have from beginner to advanced level. So you can actually explore them if you are into container world. We also talked about serverless. So while we talked about Lambda and Fargate in the compute options, serverless is not just about compute, right? From AWS perspective, serverless spans across multiple technologies, right? There are data stores like you saw S3, or there are data stores like DynamoDB or Aurora, which is like a MySQL, and DynamoDB is a NoSQL. There are databases that are run in a serverless format. So you finally don't have to worry about servers when you're running databases. You worry about data, you worry about your data structure, you worry about the querying capabilities, or how your application is going to access the data or use it. You don't have to worry about the other aspects around server management or patching and upgrading and adding security layer to it. You don't have to worry about that. Leave that to AWS. And we have a bit of a distinction, but these are serverless services. And then there are a lot of services for queuing and providing push notifications, or an API gateway, which is like a REST or WebSocket APIs, or an AppSync, which is like a GraphQL API based layer that you can create on the AWS platform. Okay. And there are a lot of other functions like step functions, where you can create multiple Lambda functions like, hey, do this, then do that. If this fails, then do this. Like you can have workflows that you can define, or state machines you can define. in the AWS platform. Then I don't want to go deeper into this, to be very honest, because there's a lot more we want to cover and we are looking at time. But there's a lot more to cover. There is also something called as Amplify. If you are into mobile development and you want to create apps very quickly on the AWS platform, do check out AWS Amplify. It allows a lot of things that it has already built. So you just have to do plug and play in your application, and you can easily use that to create your mobile applications on the AWS platform, even web apps for that matter, but easier for a lot of integrations built in. So this is something important, and I do want to talk about it and spend a bit of a time. So when we talk about self-managed, we don't mean managed somewhere else. What we are saying is self-managed on EC2. Like I showed you how you can launch a EC2 server, how you can do a lot of activities that you would generally be doing on your typical Linux or Windows or Mac OS operating system, right? But when you're doing that, let's say for example you're hosting a database, right, or proper MySQL database that you want to have on the AWS platform, you would have to do a lot of things. You would have to have the schema design, you would have to do backup and recovery, you have to take care of failovers, of patching, of applying security patches, of doing monitoring. You have to do a lot more when you're doing it in a self-managed mode on EC2. A lot of customers do that. There's nothing wrong in that because that gives you a lot of control in the way you want to host your applications on the platform, right? But it is not so convenient to keep doing the same activities. For example, if you look at here, we'll take an example of a simple service, relational database service, that is RDS. For example, we'll say MySQL is one of the engines supported by RDS. Okay, so if I have to host MySQL on AWS using RDS, all I have to take care of is the schema design, the query optimization, or how I'm constructing my queries. But I don't have to worry a lot about how am I setting up the backup and recovery, how am I setting the snapshots, like how am I taking backups, how am I doing failover, how am I doing patch management, am I upgrading it, am I applying the security patches or not. I don't have to worry a lot about these things because they don't really affect my business. These things are not going to get me revenue. What is going to get me revenue is the work I'm doing on top of these. That's why we call them undifferentiated heavy lifting, is like taken care by AWS, and you worry about your data, you worry about your schema design. And that is essentially what we talk about managed services on the AWS platform. Now, a lot of customers do that because this gives them a lot of convenience. If you are a person who needs a lot of control, you think that whatever managed service is providing and you're not able to customize it further to your need, there are a lot of customization controls here as well. But if you cannot, they are not satisfying your needs, you are always free to go ahead, start your EC2 instance and do it yourself, right? So there is a control versus convenience kind of a scale, and you can identify where does a service fits and how you're going to use it for your use case. So use them as Lego blocks that you would want. Now that I've defined that, there are a lot of purpose-built databases. Now, in the world of microservices, right, when customers are building applications with microservices where each service is doing what it has to do, like it does best, one task, why not just use a database for that particular use case? Why do you want to have a database that will span across the entire application and it may not be suitable for every use case that you have? So on the AWS platform, we try to provide a lot more variety into kind of databases we have. The more common would definitely be something like relational databases or NoSQL databases in a fully managed way on the AWS platform. Now, if you want to see a database that is not mentioned here, but you still want to use it, as I mentioned, go ahead and host it on EC2 and manage it on your own. But if you think that, let's say RDS supports MySQL or MariaDB and SQL Server, Oracle, it supports few and PostgreSQL. If that is not supported, the database that you want is supported, go to EC2. If it is supported and you want to use fully managed service, use these. Okay. So there are this range. Obviously, we're not going to be able to dive deep into all of them, but this is just a good to know information. Okay. And now I'll move on to Suman because it's something that Suman is very good at is about talking about data. So I'm going to ask Suman to take over from here to talk about analytics and machine learning, and he has some great demos to show for. So over to you, Suman. I'll keep the screen here though.
Sure. Okay. So let me pull that. Okay. So So as we were talking about compute and we talked about storage a little bit on S3 EBS volume, which is a block storage, we do have many other storage services, not only about S3 or EBS, but depending on what your use case is, we have different types of databases like Aurora, RDS, which Rohini mentioned. We have DynamoDB. All of these are various specialized database for your need. Now, having data is one thing, and then making some business-driven decision from that data that you have is a different thing. So that's where analytics comes into picture. So we have lots of different services for analytics like Redshift, EMR, Athena, Glue, and we are going to have a quick demo on Athena and Glue. But the idea is the way that you should think about data is when you are on AWS is there are few specialized storage which are meant or database which are meant to where you can just put the data and start working, right? And there are core storage is available like EBS or S3 where you can put the same data, but you have to put your own effort to make the data available for analytics, right? So you don't have to worry about all of that if you only care about your application. And we always recommend to try out our managed services because that takes away all the hindrance of managing that at scale, and that's the most important thing, how you manage the data at scale. And once you have the data or in the database in some format, you can use analytics. And the next thing that comes is once you are done with analyzing the data, you should be able to showcase that to someone, right? It may be to your client or to your management. And we have lots of different services. Like QuickSight is one of the service where you can have a dashboard with live virtualization, which will just take the data from the backend analytics platform, and you will get a very fancy dashboard to showcase what is going on in your environment or in your application. Then we have lots of machine learning related services like SageMaker. SageMaker is a managed service where you can train, you can build, and you can deploy your models at scale. But if you are a data scientist or researcher and you don't want to get into managed services that much, but all you need is a very high compute storage or a compute server with lots of memory, GPUs, and RAM, you may like to use any of our deep learning based AMIs. Just like in the beginning, Rohini shared how to create an EC2 instance. You can just create an EC2 instance which are focused on deep learning or machine learning. You can just search and you can play with any of those instances. And the beauty of those instances is those instances will have inbuilt packages installed, like let's say PyTorch, TensorFlow, MXNet, and all of that. So you can just go and start writing your code. You don't have to manage any of that. So these are the big at a very high level. These are the portfolios that we have. We have S3, we have Glue, and we have in analytics we have Athena, Redshift. In database we have different databases for different use cases, and then we have machine learning and visualization. One another thing is a blockchain, which is still it's not a area that not many people are working, but we have launched a blockchain, I think last year or last year, and it was at that time it was in preview, but you can make use of it if you are exploring or trying to do something in that front. So you can always do that. So these are the all the services that we have. Roughly, it's not the all, but it's kind of the core services that people generally use when they go for any managed service. Can you go to the next slide, please? Sure. So now what we are going to do is we are going to have a quick demo on Glue and Athena. So before we get there, what is Glue and Athena? So imagine that you have some data in your S3 bucket, okay, and now you want to query that. So one way to do that is you read that whole file, and then you go and create a database out of it, and then you create a schema, and then you write a SQL query. So that's a very lengthy process, right? But what Glue and Athena can give you is you can directly run a query on a file which is stored in S3, right? And that's what we are going to see now. So let me let me share my screen. Give me a moment. Okay, so what we are going to do is first we will store some data in our S3 bucket. So we have already created a bucket called AWS Glue hyphen Suman, and I have stored one CSV file, and I've created a kind of a folder structure, and it has CSV, and this is the file. So this is a yellow taxi tip data that that's the open source data that we got from New York taxi repository. And this data is quite big, but I've just truncated it with, and it's roughly around 47 MB. Okay, so we don't know what this data is, what it is, and what we are going to do is we'll try to use Glue and Athena to see that if we can query that data for ad hoc query. It's not for recurring use, but let's say your manager come to your place and said that, hey, can you just show me how many trips that you did in last month, or how many trips that you did a year back, right? So, and that data might be archived in S3, and you don't want to set all of that because that's a one-off kind of a task, right? So in those one-off kind of a task, you can use Glue and Athena. So let's go to the Glue console. So I have already opened in another tab. So this is the Glue console. There are a lot of things that you can do, but for now, what we are going to do is we are going to create a crawler. I've already created the crawler, but I'll just walk you through the wizard. So you click on create a crawler. That's a tongue twister. Crawler, and you can give a name. So let's say I gave demo crawler, and you can click on next, and you can just select that we are going to give an S3 bucket location next. So we can specify that do you want this Glue to crawl through all the folders or a specific folder? You can, or any new folder. So you can specify that. So let's go with the default. And here you can specify the S3 bucket. So if you remember, the S3 bucket name is AWS Glue Suman. So we'll come here and we'll try to select that bucket. So there is a bucket. So Glue will automatically scan through the hierarchy of folder structure that you have. So we can even give yellow data taxi data directly. But in that case, if you upload a new CSV file, it will not be able to crawl, right? So let's do the extreme. So let's give the bucket name itself. So once we do that, let's click on next. It also asks that do you want to have another data store? For our case, no, we don't. Again, you have to select an IAM role. As we have been talking about, Rohini mentioned it. I shown you in the Lambda demo as well. Everything is around IAM policies, right? So even if it is within your account. So we can use an existing IAM policy, or you can create a new one, because Glue is going to talk to S3, right? So it needs to have that permission on your behalf. So let's select that and click on next. Now, this crawler can run hourly, daily. So when you are sleeping, a new data might be coming in, and the crawler will crawl, right, based on the scheduler. So you can think of it as a cron job, what we generally do in Linux. So for now, we will use a run on demand. That means we will trigger only when we trigger, it will be crawling through that S3 bucket. So let's click next. And next, what we are going to do is we have to add a database. So this is not a relational database or any database that we have. This is only for Glue to store that schema, right? It doesn't store the whole data that is there in S3. It just stores that schema for you. And this is kind of a virtual entity. So you can create a new database, or you can create any existing database. So let's say I create a new database, and we can give some name like this, my DB2. Let's say any name you can give. So is the database, and now we can give some prefix. So let's say I give a prefix called Suman underscore. So this means that whenever it will crawl, it will crawl and it will get that schema and it will save it in a table, and that table name will start with Suman underscore, right? So that you know that which crawler has fetched which discovered which schema, right? These all are optional, but you can do so for better readability and you understand what is going on. Once that is all done, you can click on finish, and it will take some time to get created. I guess it got created. So now once it get created, the status will be ready, and then you can run crawler. You can click on run crawler because we have created this as a on-demand, run on demand. So that's why we have to run it manually. So one way to run it is you can just click on this and it will get executed. So now what it is doing is it is going to that S3 bucket. It is crawling through all the subdirectories, and it will try to figure out any file is there or not. If it is there, it will try to create a schema, right? So I've already created a crawler and already ran that. So once I run that, you will find the the tables in the database, right? So if you come to database, this is the database that we have created and which now crawling is going on. That's why if you go to the tables, you may not find that table because it is still crawling. But let's go to the other database, this one. And this is being used by the other crawler which I've created, and click on tables. And you will find that table is already there, right? So this table got created when I ran that crawler. So at that time, I used that taxi underscore demo as a prefix. That's why the name has come like that. And now if you see, it has already discovered the schema, right? All the fields, column names, and what is the data type of that column. And you can even edit these fields if you want to, right? You can just click on edit schema and you can edit that as well. So now you have the table, okay, and you have the schema. All you need is now to query that. So for that, we need to go to Athena. So I have already opened Athena in a different tab. So let's go there. So this is the Athena console, and this is the databases that you will see here. So if I just refresh it once, you will find that the other database has also come because I have just created sometime a moment back. So let's go to the older database, and you see that this is the table, right? Taxi underscore demo. And if you now come here and click on preview, and you can run some query just like an SQL query. So look at this now. I've just ran a simple query, right? Select from database, there's a table name, and let's see what the output is. So we see the details about that. So the wonderful part is, this is not coming from a real database, right? This data is still there in S3, but you are able to query that, through Athena. So you can also run some query, and let's say I give some condition. What condition we can give? So let me reduce the font so that I see. So let's say there is a tab called payment type, right? So maybe the payment type might be 1 stands for online, 2 stands for cash, or whatever. So you can just type that equal to, let's say, 2. So now we can see that there are payment type is, let's see, payment type is 1, 2, and so on, right? So we are now running for only type 2. So I guess there's a typo. Yeah. So now let's run that query. And now you see all the details with payment type 2. Okay. So this is what you can use with Glue and Athena to query the data in which is stored in S3, right? And not only that, you can take that data and you can put it in your data analytics pipeline, and you may like to save this in some other service, right? So like mostly Glue Athena are used with data analytics pipeline with Kinesis, Firehose, and all of that. But you can always do this, for any ad hoc query as well. So that's about the demo of Glue and Athena. If you have any questions, please do post. I'll come back to that after the session ends. Yeah. So back to you, Rohini. Okay, so I guess Rohini might not be there. Or so
Hello,
yeah,
you can hear me? Is it clear? Hello.
yeah, yeah, Rohini, we can hear you.
Okay. Just next slide. Suman?
Yeah, I can hear you. Yes, you're getting loaded. Yeah, we can see your
Oh,
screen.
okay. So moving on to next slide for you.
Yes, sure.
Awesome. That's awesome.
Okay, so the next thing is the ML stack, and these are the services that we have for machine learning. So as we mentioned, there are three different layers that we have. The bottom layer is for data scientists and researcher who just want to have a instance where they can just have CPU, GPU, and they want to get started with it, right? So you can select any kind of instances based on your need with the NVIDIA GPUs, ARM-based processors, whatever it is, and you can get started with it. Now, the second layer, which is the ML service layer, which you see as a SageMaker Studio, there, this is for data scientists and engineers who are reasonably, expertise in machine learning and deep learning, and you want to make use of SageMaker. So SageMaker gives you the capability to build and train models on AWS. All right, so you don't have to worry about the infrastructure behind that, and most of the trainings can run in containers, right? And once the training is done, those containers goes away, just like how we saw in in serverless, few of the serverless applications sometime back. So that's about SageMaker, and we can do a lot of things. Okay, so I would strongly recommend that you can join one of the conference that we are coming up with, AI Conclave, which is towards the end of the January. So you may like to join there. We have a bunch of sessions around SageMaker. And then we have the AI-based services where it's for any software developer who are not into machine learning, but still you want to integrate or have the machine learning capability in your application. So you can use any of the AI-based services. So we have plenty of services, and we keep on adding, every year. And these are the services which are API based. That means you can just call these services through an API call. So we have services for image recognition or video analysis or search. All you have to do is you just have to send that your data to the respective service, and you will get the response back. So I'm going to show you some demo on this, but before that, I guess this is the last slide, Rohini, or before that, so that I don't want to go back to the slide again.
No, no. So this is the last slide. Then we have done it.
Okay, great. So let me share my screen. Give me a moment. Okay, so uh, let's go to our AWS console. Okay, and scroll down, and you will see machine learning somewhere. Where is it? Yeah. So here you find all the services. So first is SageMaker, and that is where all the tools and techniques are available for you to build and train models. And inside SageMaker, we have lots of different feature sets. Then these all are AI-based services, right? So let's say we pick any of the services. Let's say recognition. So we are showing you in UI, but you can very well do that in your environment through CLI or SDK using Python or .NET or whatever it is. So here you have lots of different API calls. So let's say let's consider uh, text in image, right? So here you can upload any text, okay, and any image which contains text, or even if it doesn't contain text, that's also fine. It will just show you that it doesn't have any text, but you can always upload that. So let's try to upload one image. So let's upload the same image. because it contained a few text, although it's on a very odd font. But let's see. So if you see that, the request this is a request that we sent, right? The uploaded that image, and it's showing a break because it uploaded and it is there in the byte format. But in the response, you get a JSON, and this JSON contains all the words or text that it could able to detect. So the beauty of AI-based services is you don't have to train the model. You don't have to worry about training the model every frequently, because model, you need to provide new data as we go, right? Because new data makes your model much more intelligent. So you don't have to worry about all of that. This has been taken care by Amazon at their end, and we are going to give you always a ready model, which you don't have any access to. But all you have to do is you have to call this API services. So let's say, now to give you a last example of this, how it works, from your end customer standpoint. Let's say this is a web page. Okay, this is a demo which was created by one of our teammate, Nick. So this is a Node.js based app, and here, let's say we take some example. Let's say try with recognition only. So in this demo, what is now happening is, my image is coming because it is getting fed from the camera that I have. Now, when I click on detect labels, okay, I just clicked it. Now, what it is going to do is it is going to take that image from my computer, and it is going to call detect label API. Right? This is you can think of it as a REST API call, and it will send you back a JSON with all the labels. Okay, and with the confidence score, so you can make use of this information in your application pipeline. So let's try with something else. So let's try with my phone and see what happens. Okay, so let's say this is a phone, and let's try to detect. So if you see, it has not only detected mobile phone, but it also detected it's an iPhone, right? Although the confidence score is little less, but you get the idea, right? So you can make use of your AI-based services in your application to make your application intelligent or machine learning enabled, right? So this is the beauty of it. So you don't have to be a data scientist. You don't care, how they are doing it and how it is able to predict this. All you care about is how you are making use of this information in your application. So let's last try comprehend, because this is one of my favorite. So comprehend is mostly on text, and it is one of the service that we have in natural language processing, where it can detect sentiment, it can detect entity, and all of that. So let's try this out. Okay, so let's give some text. Let's say, thanks for joining. Okay, so now let's click on analyze with comprehend. So if you see, there is no entity, because there is no entity in this particular statement, but this statement is quite positive. So that's why it's the sentiment is positive with 98% of confidence score. And then there are different other things that you get. So now let's say we put some things so that we know that there is some entity. So let's say Rohini completed 7 years at Amazon. It's so awesome. Okay, so now if I run a comprehend, it is going to detect some entity. What are the entities? If you don't look at this, what are the entities? One of the entity is we have Rohini, which is a name. Then we have Amazon, which seems like an organization. But let's see what that model predicts. Okay, so the model has identified Rohini as a person, and it has also identified that Amazon is an organization, right? So these are the things that you get, out of the shell, from AI-based services, and it also gives you what is the offset. So you know that if within that text, from where to where that particular text word or the word is there, right? And there are a lot of things that you can do. Even you can do text modeling, and it can detect, given a sentence, whether it's a noun, pronoun, verb, etc., etc. So you can do a lot of these things. These are just the 4 API calls which we have incorporated in this particular demo, in this particular application. But comprehend can do a lot more outside this. So this is the power of any AI based services. And we keep on doing more and more. We are keep on coming up with more and more AI based services, based on the customer requirements, right? So Comprehend was not there before, and then once we launched Comprehend, we got a lot of positive feedback from customers, and they said, okay, can we do this for medical data, right? And then we came up with Comprehend Medical in last reinvent, I guess last reinvent, and that's how we evolve, right? So if you are a data science, if you are a software engineer or software developer, do check out all the AI based services and see that if if any of the problem that you are trying to solve today, but you don't have the expertise in your organization or team to build, train, and all of that a model for machine learning, you may like to leverage these AI based services. So that's all I have from my side. So I'll give it back to Rohini, and then I'll take some questions.
Awesome. Thank you. So that was analytics demo, AIML demo. We also showed you something about serverless, something with storage, and content delivery network. There is still VPC pending, so I will be doing that. And this is more towards the people who like to look at architectures or want to understand. I try to showcase that in an architecture format, right? Um, so before we go there, we have to talk about security because I mentioned, right, security is a priority for us. It's the number one thing for us, right? So for your AWS security, right, there is a shared security model, shared responsibility model about security at AWS, right? What we mean by that is that you AWS as a customer will take care of the security of the cloud. So the data centers, the physical security or security of the services like compute services, the basic core services that AWS gives, security of these services is a responsibility of AWS. Okay, so we take care, so you don't have to worry about physical security of the data centers or the regions or the availability zones. That is something that AWS will take care of and is responsible for. A customer is responsible for the security in the cloud. Now, what we mean by that is if you're keeping data into, or let's say you created an EC2 instance, now up to the operating system that we are giving you or doing patch management up to that image is something that we will take care of. Once you launch that virtual machine, do you want to do patch management? Do you want to do install new updates? That is something your responsibility. If you're storing data on that EC2 instance, how do you want to secure it? Do you want to have firewall rules in security group? What do you want to have encryption or not? Do you want to have antivirus solution or not? That is something is your responsibility. Now when we are saying is that it's your responsibility and my responsibility, it doesn't mean that we are handing over saying, hey, it's not something that I'm responsible for. What we are saying is we are giving the flexibility of doing that to our customers. So consider this: one of the students who want to access AWS cloud may not care about encryption, may not care about a lot of security rules that a lot of enterprises may have. Enterprises may have a lot of processes, they have a lot of things to take care of before they are considering going live in their environment, right? So that's a whole range of what kind of security processes, what kind of security principles or rules people want to apply, right? So AWS gives you that flexibility. We give you the tools that you need to ensure that your environment is secure. For example, like you saw the example, right? Like in EC2, you could also say, hey, I want to encrypt the block storage. You can do that with just a click. Or we give you security groups, which are firewalls for your virtual machines. You can decide what ports you want to open. By default, nothing is open, right? But you can define what ports you want to open. Do you want to open it for the whole world? Sorry, for the whole world, or do you want to just open it for your own IP address, right? So you as a customer have to take care of that security model, and this is very important to understand because this is very important to understand because if you're attempting to work on the AWS platform, you also need to understand security, and if you're a developer as well, right? Like security is now everyone's job today, so we have to understand how it works. The next is definitely, I'm not going dive deep into security because it's a whole topic in its own, but these are the major categories into which AWS provides a lot of security, from identity access management to detection of what is happening, to protecting the environment, to protecting the data, to doing incident response activities, and even new services around compliances are being released from AWS. And we are continuously doing more and more in this portfolio. There is a specialty exam for security as well. So if you are into security, you may want to check out all the services or the examination itself. So if you're starting on AWS, right, and if you are an ops person, you may want to start with a simple thing. Something very simple is like a LAMP stack on AWS, right? You have an EC2 instance, you launch an EC2 instance, you launch a relational database service with, let's say, MySQL, and you have a VPC and uh, everything around it. The link is available in the description. So go ahead, check it out. Do this should take you an hour or two. If you're new on the cloud, just make sure you're using free tier eligible resources, and you're terminating resources once you're done with the experimentation, right? Now what I want to do is, in the next slide, is walk you through the networking architecture. Now the reason I'm showing it in an architecture and not in the console, it may get a bit confusing if you're seeing it in the console as to how these different resources relate to each other. And that's why I wanted to tap into my architect persona, and showcase how you can imagine the VPC structure, the virtual private cloud, or how these virtual machines are created in the AWS environment. If you're planning to do certifications, please take note of this. This is very basic, like there is a lot of advanced stuff, but I've tried to keep it to bare minimum basics of VPC. Okay, so let's get started. So the first thing you would do on AWS is select a region. Now, a region could be a region which is closest to you, or region that is closest to your customers, or a region that is very cheap. If you're experimenting, go and launch stuff in US East, because you don't care about latency. You're just experimenting. You just want to do it at a cheaper cost. Maybe select something like US East as your region. And most of the new stuff that we launch gets into US East. So if you're one of those people, you may want to go ahead and do that. So select one of your regions in the AWS cloud. Okay, so you selected a region, and you remember I talked about availability zones and multi-availability zones and HA and fault tolerance. So let's consider that that region has two availability zones or more, but for the simplicity and keeping the diagram clean, I've selected two availability zones that I want to work with. Okay, then you create something called as a virtual private cloud. Now, creating a VPC is very simple. All you have to give it is this CIDR block. This is the IP range of your virtual private cloud. Remember, it is saying virtual, that is its logical, and it's a private cloud. So you're giving the private IP address CIDR block, CIDR block or CIDR block, and creating the virtual private cloud. And a lot of the resources in AWS or services in AWS are either to be created inside a zone or inside a region, or they may be global. Now, if you come from a programming background, you understand the scope, right? So similarly, a lot of services or a lot of products or features or whatever you call it, resources will have scopes. So either they will be inside a zone, either they will be inside a region, or they may be global, so they can apply it across all the regions, right? So if you notice, VPC is inside a region. So it's a regional service. Okay. So VPC applies to the entire region. Then you create something called as public subnets and private subnets. Now, subnets are nothing but smaller sections of the entire VPC that you have. So if my entire VPC was of this particular CIDR block, I've just broken it down into two different subnet blocks. Now, I can select how the subnet block should look like, but I've just taken an example. When I'm creating the subnet, I'm creating it with the CIDR block. Now, the important part, what is public subnet and private subnet? And the entire slide that I'm going to show you is going to dive deep into the public and the private aspect of it. There is no way you say, hey, create the subnet and it's a public subnet. It doesn't work like that. How it happens is, let's say you create virtual machines in both the subnets. Okay, I'm created that T2 micro Linux virtual machine in both the subnets. Now, note this, that it's not just about EC2. A lot of the services in AWS, especially the core services, will use something like a VPC. So knowing your VPC networking basics is very, very important if you have to work with AWS. So I've launched these EC2 machines. These are Linux machines I've launched into each of the subnet. Okay. And I've created a security group. You remember I was talking about firewalls, I was talking about security groups. We opened port 80, we opened port 22 so that we are able to access the contents of these EC2 instances. Okay, so I've created a security group boundary for each of these EC2 instances. With me so far? Then what makes these subnets public or private depends on something called as a router. Okay, so by default you will have certain routers created. What I do is essentially I created some routers on my own. So I've created a router for public subnets, I've created a router for private subnets. By default they will have a local route. So what it means that, and the local route is for the VPC. Does this match the VPC? Yes. So local route is for the VPC. That means any instances within that VPC, even if they're in different subnets, even they're in different availability zones, they will still be able to communicate between them because the route is for local VPC discussion. Okay, so this communication sounds good. Okay, if I need to access this virtual machine from outside, remember how I connected to that virtual machine? I need to attach something called as an internet gateway to the VPC, and I have to mention in the router, hey router, if I have to go to internet, that is 0.0.0/0, please go via the internet gateway, and this could be ID for this internet gateway, right? So what happens in this case is, let's say I'm a cloud admin, I've created this environment, I'm not an end user who's accessing the app, I'm the cloud admin who's creating the AWS resources, right? I am going to say I'm cloud admin, I need to access this EC2 instance in a public subnet. I can do that easily on, let's say this is Linux, so port 22. Okay. But can I access something in the private subnet? Sorry, you cannot access that because there is no route for you to come in or for this instance to go out. It's only going to be able to talk inside the VPC itself. So a lot of people will ask then, how do I access these instances that I've created in the private subnet? Well, there are ways to do that. The first thing is you create a public subnet, and I'm just assuming this is the same subnet, but you could create a separate public subnet for all these activities like the ones I'm going to describe here. But let's assume that we upgrade this EC2 instances work or task to become a bastion host or become a jump box or a jump server. What essentially we mean by jump server is, if I have to access this machine, what I'm going to do is I'm going to access this machine, and from here I'm going to jump to the private subnet instance. Okay, so let me see if I can show that. So that is the way you're going to access it. And this is what a lot of bastion hosts or jump box or jump servers. If you search for AWS EC2 bastion host, you'll find a lot of more information on how you can create that for Linux or Windows and how you can access it and how you can secure your application. So what happens is anything in the private subnet is not accessible over the internet. I can store a database here that doesn't need to be accessed from anywhere else. It may be only usable in the AWS environment or to the applications I've given access to. Okay, with me so far? So we talked about incoming, right? So this instance, we talked about incoming requests into that EC2 instance. What about outgoing? Can this virtual machine go out to the internet? No, because there is no route here talking about outgoing as well, right? So you would say, hey, I think this is a let's say this is a Red Hat instance, and you're saying that, hey, I need to go to Red Hat's repository to go ahead and download some kind of updates or security patches. Remember, patch management is your task here. So how do I go out and do that? What do I do? Do I set up a local repo? Can I go out to the internet? Yes, you can. But for that, you have to create something called as a NAT gateway. Okay. And a NAT gateway is network address translation. So what NAT gateway's job is to get a request from the instance in private subnet, say that, okay, this is this is a request that you need, this is where it has to go. But when it is sending the request out to the internet, it is actually going to send a request out saying I did that. Instead of it, so it will mask who asked for that request, and it will provide its own IP address, get that request, and you can do whatever scanning you need, or you can just pass that information back. So no one really knows the IP address of this virtual machine that was actually originally asking for that update. So you are actually doing network address translation using the NAT gateway. Now, as a best practice, we want NAT gateways to be created in every availability zone. So if you have two availability zones, create one in each availability zone, because you don't want to choke the network capacity of that NAT gateway, right? So you create that NAT gateway, you say route table. Now you have to go to the internet. So see the difference. Okay, you have to go to the internet via this NAT gateway, and automatically any request that from here has to go to internet will go via the NAT gateway. You don't have to do anything else. If you have just created a NAT gateway, updated the route table, that's it. Okay, so remember this, because this is something that typically comes a lot when you're doing VPC examples. There are a lot more complications. We'll not go there. We'll just keep it simple today. Okay. Now let's go back and clean the slate. Now, for example, think of it that I've created some public subnets, I've created some private subnets, and now I want to have that 2-tier or 3-tier application that I've created. I want to create that in AWS. Now, this architecture is kind of a best practice architecture. It doesn't have to be this complex if you're just starting out and playing with it. But if you're trying to go ahead for the Solution Architect Associate or professional exam, you may want to pay attention to this particular architecture. Okay. So there's public subnets, two private subnets, each in two availability zones. So let's get started. The first thing I want to create is web servers with multi-availability zones. So I'm going to try and use both the availability zones for fault tolerance and HA. And I also want to do automatic scaling. What I mean by that is there are two types of scaling, right? There is vertical scaling, where I can have the same machine, and that machine, let's say it's 2 vCPU, 8 GB RAMs, but I want to upgrade it to 4 vCPU and 16 GB RAMs. That is vertical scaling. So you're adding compute or resources to the same virtual machine. So that is vertical scaling. This cannot be automated. It is there is a bit of a downtime for the machine to stop and change and come back, but this cannot be automated today, right? What you can automate is, if I have a 2 vCPU 4 GB machine, and I can add another 2 vCPU 4 GB machine, or I can add a 4 CPU 8 GB machine, I can automatically add virtual machines horizontally and be able to automatically scale. And there's a service called as auto scaling in the AWS platform. The first thing you do, always, the first thing you do is create a security group. And always remember that you're going to create security groups per tier. So if there's a web servers, I'll create security group for them. If there is a database servers, I'll create security group for them. Create layers of security group. Don't just use the default security group. It's a very, very, very bad practice for doing that, right? Create separate groups for production environment. Create separate groups for your test environments, right? So separation is more important, because that's how layering in security works. So we have created a security group. Now we create EC2 instances, we configure them. Let's say the example I showed you, that HTTPD is installed. Maybe you want to do more configurations. You do all these configurations in your virtual machine, create a machine image out of it, and tell autoscaling, use this machine image. I want these number of instances of this particular type. And depending on the demand for my application, for example, the CPU is increasing, add more virtual machines, or more users are connecting to my application, add more virtual machines, or the demand is less, everyone's sleeping, just come back to two virtual machines. Auto scaling can do all of that. It's a good topic to dive into. And if you're doing SA, you solution architect or operational or SysOps certification, do learn auto scaling a lot. You create auto scaling, and you create something called as a load balancer, and associate that load balancer with auto scaling. So any requests that are coming in will come to the load balancer. Load balancer will take care of distributing those in your auto scaling instances. Okay, so it will distribute to both the availability zones, or how many availability zones you have configured, but it will distribute across. So for example, if this availability zone fails, load balancer will know that, okay, instances in here are not responsive, they are unhealthy. It will start sending your request here. Auto scaling will automatically start creating instances in this availability zone as well, until the zone is recovering. So it's a very smart system that is automatically created for you to work with. Okay, then I want my last year, obviously I need to persist some data, right? So I need to have a database layer. So database security group, I create a primary database. So now here example I've taken is of RDS MySQL, simplest of all, right? Relational database service. I'm using a fully managed service for MySQL. I've asked it to create a primary database. And what I need is, let's say I don't want to worry about, how am I going to do a backup, or how am I going to do failover, how I'm doing HA. RDS has a flexibility where you just do a tick mark. It will create a secondary database. It's called as multi-AZ as an option or a feature. But what RDS does in the backend is it creates a secondary database for you in the backend, and it synchronously replicates your data to this database. Okay. So RDS does this automatically for you. So you don't have to worry about what happens if my primary fails, what happens to the data. Obviously, there is backups and everything else separately, but there is also synchronous replication to another virtual machine in the backend. Obviously, you pay for both of them, but you only access the primary in this case. But your data is secure for your application. And I'll talk about the failover strategy towards the end. Now you've created web layer, you've created database layer. We also have an S3 bucket. I'll just piggyback on Suman's example of storing static content on S3, right? Then he added a CloudFront distribution. We all saw that. And for example, if a client, like Suman's example, right? Suman is a client. He's accessing his application. That goes to CloudFront. Now, if you have set up HTTPS, it will go and access the application on port 443. If it is for the static content, it will go to S3, show the page to the client. If it is for a dynamic content, the user is trying to, let's say, register something or check out for more information, the request will come to first Elastic Load Balancer. Now, in this case, I'm not configured SSL here. I've only configured SSL at my CloudFront. So all the requests that will come to the Elastic Load Balancer will be on port 80. Okay. Post that, Elastic Load Balancer will forward all those requests to all these auto-scaling EC2 instances on port 88. Okay. So I've kept a different port for all of them to talk between load balancer. What EC2 will do if it needs to go to the database, just a simple example, it will use port 3306 to talk to the database. Now you notice how I've kept it from red to red. So what is happening is only the web security group, web server security group can send requests to database security group. So what I've configured in database security group is anything that has to come inbound will only come from the web server on this particular port. I don't want anyone else to coming in inside my machine. And this is how you're improving security. First of all, this instance is not available from the internet because it's a private subnet. We have not given access to internet. Secondly, the only access I'm going to allow is from the EC2 instances and nowhere else. So my database is very, very secure in this sense. Now, what happens in the backend is when you create RDS, you don't get an IP address. You get a DNS name. Okay. What happens in that case is in a DNS name is RDS will give you that DNS name and you should use that DNS name. The reason is that DNS name in the backend actually points to the primary database, okay, in RDS. So what happens in this case is that if there is a scenario of failover to the secondary, okay, so let's say the availability zone has issues, the instance is going crazy, or there's some issues, and we have to fail over to the secondary. In the backend, RDS will just have to point from primary to secondary. Your application doesn't need to update because your application is pointing to a DNS. And what that DNS points to in the backend is something that AWS will take care of, right? So you don't have to worry about it. AWS will move the pointer to secondary, make the secondary as the primary, and create a new secondary again and start doing the replication again. So this is the way that AWS will take care of the failover for you. Your application may have a minute of downtime, maybe maximum a minute, unless you're doing caching and all, you won't see that difference at all. But it may be a minute because the DNS has a time to live, like a TTL for it to expire, but it will move on, right? So this is the typical 2-3 tier architecture that you can see on the AWS platform with a lot of details in this. I know it is a lot of details. Maybe you want to go ahead and experiment and come back and watch this again, and you will be able to relate to what I'm trying to say. So all of that, this is how complex it can get just for a 2 to 3 tier architecture. So start small, start with a very basic thing, and then start building these, as I mentioned in the screen as well. Start with one part, learn about it, then start building and adding these different components. And you'll see how these different services can be used as a Lego block to create your own application architectures based on your different use cases. Okay. I know you have been listening to us for a while. Just stay tuned. We are almost towards the end. We just want to talk a bit more on training and certification possibilities on the AWS platform. Suman, you may want to be on the screen because we both, I mean, you can add a lot more than me do, but let's talk a bit more from training and certification. So, for a training perspective, there's lots of training available. Okay, there's definitely like you cannot ask for more training. There's so much training available there. There are free digital trainings from AWS. We have our training partners. You can also use those training partners to actually Udacity, Udemy. There are training partners. There's still a lot of content on YouTube. So there's a lot of things to read, right? And a lot of people ask, like, where do I start? There's so much content. How do I even begin somewhere, right? You should start with ramp up guides. These are by roles. So if you're a developer, this would be for a developer. If you are a cloud practitioner, you may want to start from a cloud practitioner perspective. Or you may be into machine learning or game tech, you may want to start with that. Use the ramp up guide because it's properly layered as to what should be a step one, how do you read about these things, and how long it will take to move on to the next one. I'll just wait for someone to add in here as well.
Yeah, sure. So I guess certification is very important to upskill your skill sets. And one of the important thing is I'm not a very big fan of certification, but I'm a very big fan of following a certification track. Right, that's very important. So as Rohini mentioned, you can pick up the track that you are mostly passionate about, and then go from there. Otherwise, if you just jump into learn cloud or AWS or anything in general, that's quite crazy. And the architecture diagram which Rohini spent some a decent amount of time, I think that is a very important fundamental, right? And it might be it might be a little daunting in first place, but once you get each and every piece separately, once you look at that separately, that's not that difficult, right? So I think you can go ahead with the associate level certification, and if you're very much new to infrastructure in general, then maybe you can start with cloud practitioner, which is in the bottom. But if you have worked in any infrastructure in your past, whether it's on-prem or anywhere, then I guess you may not need this cloud practitioner. I guess someone asked as well. So you can go ahead with that if you're completely new. Otherwise, you can start off with the associate level certification, and then go from there onwards. You can go to professional or any specialist, and there is no prerequisite as well that you have to go in a hierarchical fashion. It was there previously, but if you are into machine learning or if you are into networking and you have been working on cloud for quite some time, then you can directly take a cloud networking specialist or machine learning specialist certification as well.
Yeah, definitely. Like cloud practitioner, I would say learn for cloud practitioner, but don't give exam a cloud practitioner. If you're a techie, you may just want to start with associate. We're just trying to save some dollars for you here by giving that advice. But if you are someone who is not a techie and you want to just get that stamp that, hey, I know AWS, maybe you want to give cloud practitioner as an exam and move on. Definitely a good point there, right? So almost towards the end, we do want to talk about our AWS user groups, and we definitely have seen a lot of interest from a lot of people across the country, and definitely we have user groups everywhere. Last year, this year was a bit difficult. We had to go online, so we also have our own YouTube channel where all of us try to get content. We like to get speakers from the community. It shouldn't be just us AWS talking to all of you. It's a user group for all of you. So if you are learning about cloud, do sign up for these user groups. Do sign up for these pages because there's a lot of people who are talking about it. If you're someone who wants to talk to people about what you have learned, definitely there is also a way of doing that. You could be writing your own blog, or you may want to give a presentation. Do reach out to your respective city or the user group leaders there, and they should be able to help you get a slot for speaking at one of the user group meetups. And finally, this is a best way to meet up people. And there are a lot of opportunities that come out, right? There are people who want to do certain projects they need help with. There are people who are doing hiring. So it's a good way to connect with a lot of people who are into the same space. So definitely use the user groups for that. Suman, anything you want to add that I may have missed?
No, I guess you mentioned all the important points, but just one small note is, let's say you are into a city where you don't find any user group nearby or in your city. These days it's online, so it doesn't matter. But yeah, we are talking about the normalcy. In normal condition, if you are passionate about working with the community, and you're already working in some community, in some in some other tech community, you may like to start a user group in your city or region as well. Do reach out to Rohini or me or anyone you are aware of in the AWS user group community. Someone of us would help you to build that community, and there are lots of advantages to be a part of the AWS user group. Not only from professional standpoint, but from personal standpoint as well. All right. So, but the
Definitely.
point, you need to get connected with user groups to stay connected with the latest technology around. Yeah.
Definitely, and our AWS heroes and our builders are coming from the community itself, right? So if you are one of who's passionate about all these things, it's definitely something that we recommend you to come and join and talk about it, because a lot of our community user group leaders are heroes from AWS, and they have been doing amazing work in this space. The next thing, or the second last thing that I want to touch upon, and I've kept best for the last, definitely, but the events, right? There are a lot of events that keep happening from AWS perspective, from the community perspective. Sign up for one of the events, and definitely will keep getting a lot more information about the new events that keep coming. But these events are meant for particular kind of people, right? So Innovate or Awesome Day are more for people who are new to the cloud and they want to learn a bit. Most of these are free, so you can join these, see the topics that make sense to you. And like Innovate has its own AI/ML conference as well. So if you're into that, go ahead and join that. If you're just coming new and you want to just have basic core understanding of core services, Awesome Day online conference is best to start with. We also have a summit coming up again this year. Every year we do summits in major cities or major countries of the world. So it's a good way to know about the different customers or different collect customers that are working and how they're using the cloud, and more information, right? And then of course reInvent is there, that just happened recently. AI Conclave is coming up in January. Community also does its own community day, where all of the community people come together and deliver talks and help the community grow and learn on the AWS platform. So coming to our last line. This is definitely my last line. But last slide, do want to give you, like, a lot of people ask, like, there's so much to do. How do I make sure I'm successful in my career? How do I get started with my career? And what I want to say is, know your basics, know the different cloud terminologies. There's a way that there's a different terminologies that clouds have come up with, like serverless, right? Which didn't exist before cloud came in, right? So try to learn these different terminologies, try to compartmentalize. Okay, this maybe forms into development, or this may forms into analytics or machine learning. Try to compartmentalize, try to learn a bit more about these basics. The second is, know your area of tech. Like we have mentioned this many times in the presentation today. Know what you want to do. Like you're into machine learning, use that and then explore AWS. You will definitely learn quickly, and you will be able to ramp up much faster. Hands-on practice projects. Theory reading just everywhere else is not going to help you at all. Do as much as hands-on practice that you can. Do workshops. There are a lot of hackathons, workshops, internships. There are a lot of mentorships happening. If you don't want to spend a lot, maybe look for certain workshops which give you credits for playing with their services. There are a lot of workshops that keep happening. Even we do it, our community does it. A lot of hackathons happen. This will give you certain projects to work with, and it's a definitely great way to start learning. Document. If you are doing these projects, if you are doing some coding and stuff like that, start writing, because people nowadays use social media very well to showcase their capabilities of what projects they have been doing. And this is for people who may not even have experience a lot, and they want to showcase that they know a lot. for them, blogging, vlogging, use your GitHubs, use your LinkedIn post, showcase what you have learned, what you know, because that really helps you. Because, people ask this question, right? I don't have an experience in AWS. How will people hire me? And if they don't hire me, how will I get experience in AWS, right? So this is a great way to create your own projects and showcase them via these different mediums. Networking, use social media, use the secure community group, um, use that for networking, ask for help. If you need help, reach out to us. There's a lot of experts you can reach out to. Please reach out to them. Ask them for proper help. Don't just say, like, give something like in the Hawa, like, I want to learn this. How do I get started? Like, do your research and then, ask for help. And obviously, training and certifications. Uh, find free trainings. There's a lot of information available. Use certifications to evaluate your understanding, and that should be good. Suman, you want to add anything before we go to the end of this presentation?
No, that's all. And one small thing is, on certification part, because we get a lot of questions around that, on certification fees and all of this. So when you write any exam, and when you clear that, you as a goodies, you get a discount coupon as well. So 50% discount coupon. So it's only the first time you pay 100%, but after that you always keep on getting 50% discount code. And that is on the certificate track. On the last thing which Rohini mentioned on documents, and that is very, very important. These days, if you're a fresher or coming from college directly, we really don't care about from where you are coming. Okay, so all we care about, how what is your portfolio, and you can build a portfolio with your GitHub account or with your blogs or projects. So that's what showcase your credibility and interest, rather than just saying we want to get into cloud, right? So I think these things will vouch for you rather than your resume. So it's always recommended to get into these user groups and other communities and start contributing, and don't have to worry about, I'm not that polished yet. So it's still day one, as we say, right? So just
Always day one.
yeah. Right, yeah, that's all from my side. Yeah.
Lovely. So that's us. Reach out, follow us on Twitter, LinkedIn, reach out to us. We'll definitely be happy to answer a lot of questions and talk to a lot of you. And with that, we end this presentation. Thank you, everyone. And if there are any questions, we'll take them now. Or do you think we have answered most of the questions? Did we miss out anything?
Yeah, I guess we covered everything, all the questions. There is no pending question that we have at this point.
Great. Okay. So if you still have more questions, guys, please reach out to us. The, how to reach out to us is on the screen. There is also a lot of discussion around cost. Is a big topic in its own. We will definitely try to answer a lot of the questions around security and cost, and all of these topics that we touched upon are much, much deeper. So please do follow us at places we are. Um, follow the community, because these may be answered already, and you may just want to do a search and attend these sessions, right? So thank you so much for joining in, and thank you for staying for almost 3 hours. Have a good weekend. Thank you, everyone.
Thank you so much. Bye bye.
Okay, so yeah, really awesome session, guys. I really believe it was a really engaging session, and there's so many questions, and you guys were at speed. You guys were answering them offline as well while continuing with the session. I hope everybody who joined us today, like got a really good insight into like getting starting with AWS. And yeah, guys. So if you do have any more queries, please reach out to Rohini and Suman. All their like social media links are provided in the description below. And yeah, if you have any more questions, this is the last chance for you to get them answered live. So any more questions for like Rohini and Suman?
Yeah, this is the last chance for today. You can after the session, but yeah, keep in touch. With the social via any social media platform that you are in, And feel free to reach out to us, and we would love to help you, to get started or during your cloud journey with AWS.
All right. I don't see any questions. So thank you so much, Rohini and Suman, for joining us today and like sharing your expertise and your insights on getting started with AWS. So hope we do a session really soon as well.
Thank you, everyone. Thanks.
Thank you.
So yeah, so that wraps the session for today. Hope you guys had a really good session today, and yeah, feel free to comment in the comment box what kind of sessions you would like us to do. So this was like our inaugural session by the AWS UG Tirupati. So hope you guys liked it, and yeah, like I said, do let us know what we can present on and what topics to be covered in our next sessions as well, so that we can try and put out more like engaging content for you guys. All right. So awesome meeting all you guys here. So, and see you guys in the next one. Yeah, peace.